I acknowledge the traditional custodians of the various lands in which you're all joining us from today. I also acknowledge any Aboriginal or Torres Strait Islander participants. I pay my respects to elders past, present and emerging, and celebrate the diversity of Aboriginal culture and connection to the lands and waters of New South Wales.
Hi, I'm Kelly Lees, Education Officer Honeybees for the New South Wales Department of Primary Industries based at Tocal College in Paterson. Welcome to the 42nd Annual Tocal Beekeepers Field Day. Thank you so much for joining us online again. And we've got a great lineup of speakers for you today, so I really hope you enjoy the day. Don't forget to join us. We've got 2 live Q&A sessions, one in the morning and one in the afternoon. So do send your questions through so that they can be answered by our experts. Have a great day.
Good morning everyone. My name's Bianca Jiggins. I'm a Student Administration Assistant for New South Wales DPI at Tocal College in the Honeybee Education team. This year's 42nd Annual Tocal Beekeepers Field Day is proudly brought to you in collaboration with Australian Honeybee Industry Council, the New South Wales Department of Primary Industries, the New South Wales Amateur Beekeepers Association, the New South Wales APRIS Association and the Ween Bee Foundation.
Good morning and welcome to the Tocal Beekeepers Field Day. I'm Julie White and I'm currently Acting Centre Director and Principal of Tocal College. And it's my pleasure to welcome you to the 2021 Beekeepers Field Day. I would like to acknowledge elders past, present and emerging as I stand here on Wanneroo country. We are very happy this year to be able to bring you an amazing range of speakers and to provide you with the latest information on what is happening for the beekeeping industry in New South Wales. New South Wales is a huge part of the national beekeeping industry, accounting for 45% of honey production with 12,000 registered beekeepers. So it's really important that we have days like this to enable the industry to continue to develop and to be in touch with the latest information that hopefully you'll be able to take away and apply to your enterprise. I would particularly also like to thank our supporting organisations, our partners, who are really a key part of this event also, and that is the Australian Honeybee Industry Council, the New South Wales APRIS Association, the New South Wales Amateur Beekeepers Association and the Hunter Valley branch of that, and the Ween Bee Foundation. So great to have that support and really fantastic for the industry that we have this level of cooperation occurring. So I hope you enjoy this virtual beekeeping day. We were looking forward to welcoming you here in person, but I'm sure that you will get a great deal of valuable information out of this virtual event, and we'll see what next year brings. So please enjoy our speakers that are coming, and I look forward to one day being able to welcome you here in person to the college. Thank you.
Up next is Trevor Weatherhead from the Australian Honeybee Industry Council, or ARBIC, talking about the importance and relevance of ARBIC for the Australian beekeeping industry.
Thank you for the opportunity to present on behalf of the Australian Honeybee Industry Council at your Tocal Field Day. I know the Tocal Field Day has been going for a long time, and being virtual now is a little bit different to being able to get together and talk to all your friends. So in ARBIC, as we say, we are the peak body supporting a small industry, and our industry has a very big impact. So who are the members of ARBIC? We have the Queensland Beekeepers Association, the New South Wales APRIS Association, the Victorian APRIS Association, the Tasmanian Beekeepers Association, South Australian APRIS Association, Bee Industry Council of Western Australia, the Honey Packers and Marketers Association of Australia, the National Council of Crop Pollinators, the Australian Queen Bee Breeders Association, and the Amateur Beekeepers Association of New South Wales. So as you can see, they're all the peak bodies of the beekeeping industry in Australia. We sort of don't have individual members as such. The members are the peak bodies. So what does ARBIC do? ARBIC represents the beekeeping industry at the national level. And ARBIC works hard on the biosecurity area to keep exotic diseases and pests out of Australia. That's one of our primary reasons there. And we're a source of information for Australian beekeepers. So what issues are around at the moment that's affects us? To help us in these issues, we have several subcommittees. We have a resources subcommittee because it looks at the resources Australia-wide, not just in a particular state, but they can help out. And we know that resources is probably the number one issue for beekeepers in Australia. If we don't have resources, then we don't have a beekeeping industry the way we know it. Biosecurity, as we all know, things like Varroa are not present here in Australia. We have had the eradication program that got rid of it in Townsville. And so we keep fighting very hard to keep Varroa out of Australia. And there's a few others like tracheal mites, the Tropalaoaps mite. We don't want them here. Asian bees from other parts of Asia, or the Africanized bee, we don't want them here either. So biosecurity is one area where our subcommittees work hard. We have a producer contingency fund, and that is in charge of a money that was left over from the old Federal Council of Australian Apiarists Association days when they had a contingency fund there, and that is available to be used by industry. But you have to have an application that goes there to work on that. Education is probably a very important part for our industry, particularly in training up trainees for commercial beekeepers, but even just for educating anyone who wants to know a bit more about beekeeping. We have the Congress 2022 committee, so we have Congress coming up next year in Sydney at Rosehill in June. So it'll be a very important part, and planning is well underway for that through our subcommittee. And we have a Queen Bee and Importation subcommittee. As you would know, that queen bees can't be imported straight to the beekeeper in Australia. They have to go into a quarantine situation where several checks are made of their bees and the escorts that come in to make sure they haven't got any diseases or pests with them. And then only the grafted larvae are available to the person importing, and they take them away and rear them up as queen bees. So they're the subcommittees that look after some of the issues that we have within our industry. And of course, we're looking at a national newsletter at the moment. Not sure how that one will go, but the suggestion has been made that we should have a national newsletter over and above what we have now for our ARBIC newsletter. So we'll see what comes out of that particular subcommittee. So on the biosecurity, the National Bee Pest Surveillance Program is currently being reviewed. This is where we have hives at different ports that are there. They're checked every 6 weeks to make sure they don't have any exotic pests or diseases in them. We also have other people that go out and check the port area. Foreign bees go and look at the flowering plants within a port to see that there's nothing there. And the bees, the samples are taken out of the hives that are at the ports and checked regularly. The bee biosecurity officers were established under the National Bee Biosecurity Program. So each state has one. South Australia at the moment is going through establishing a new one, but previous one did resign, but they're all employed under the National Bee Biosecurity Program. The National Code of Practice was adopted by industry back about 2016. So that's a guide that if beekeepers follow it, they should be able to work well within industry and keep the industry going well. And the BBOs help beekeepers adhere to that code of practice. So they're out there to help beekeepers. They're not there as a regulatory type person. They're there to help them. And as we know, we've been successful in eradicating Varroa jacobsoni from Townsville. That has happened, so we're very pleased with that. The last thing we want is Varroa here in Australia. For our Congress, as I mentioned before, it's the fourth time that we were held an Australian Bee Congress, 8th to the 11th of June at the Rosehill Racecourse in Sydney. We had the last successful one was 2018 on the Gold Coast. In 2022, it will be 200 years since the honeybee was successfully introduced to Australia. So we're celebrating 200 years of honeybees being here in Australia. So make sure you put that Congress date in your diary now, and more information will be coming out, re-registration, areas where people could support the Congress through sponsorships, through the trade show and things like that. So that will be coming out very soon. Finances. ARBIC would like to thank those who have made voluntary contributions as friends of ARBIC. For ARBIC to represent our industry at a national level, ongoing financial support of both the packers and the beekeepers is needed. There has been some confusion between the statutory levy and the ARBIC voluntary levy. So the statutory honey levy is what you pay to help finance certain areas of our industry, things like research and development, the emergency plant pest response deed, the national residue survey. So that's a statutory levy and you have to pay that one. ARBIC is run by voluntary contributions through our friends of ARBIC, situation where people, beekeepers and packers and other people make just contributions so we can run. So if you're not already contributing to ARBIC, I would urge you to do so and keep connected with your national body that represents you. So it's the only way that our industry can work is through the contributions through our friends of ARBIC. Meetings, we have all sorts of meetings during the year. We have Plant Health Australia. ARBIC is a member of Plant Health Australia, so we have input there. We've had bushfire recovery work that's going on, the levies collection unit, the food import section, where we're still trying to have more food inspected as it comes into Australia. Minister Littleproud and his staff on the various issues that crop up from time to time that affect beekeepers, so we have to go and see the Minister. The Almond Board of Australia, we have a very good relationship with them, and it's only been this past August that the pollination of almonds was in place, and we have a working group that went together to make sure that beekeepers from interstate could get into the almond areas to be able to pollinate the almonds. And I've heard that apparently they get a very good pollination this year. And so, as I mentioned, we had that working group for getting the hives into the almonds so the beekeepers can move in and out without having to come back and quarantine when they got home. We talked with the Australian Pesticides and Veterinary Medicines Authority. They're the people who register all the chemicals, so things like pesticides and that. If there's any problems, we can talk to them. And talking about that, if you have a problem with your bees getting killed with a pesticide, there's a thing called an adverse report that you can send in the Australian Pesticides and Medicines Authority. I urge you to do that and put in this adverse reaction report so that they know that something has happened. FSANZ is Food Standards Australia and New Zealand, and we talk with them regularly about that. Coming back to our communications, so ARBIC is working on a new industry communications plan. So we have now established, and you can follow us on Facebook, on Twitter and Instagram. So if you're into that, log on to the ARBIC sites there. A new website will be up and running soon. If you wish to receive the monthly ARBIC newsletter, which only comes electronically, please send an email to the ARBIC office asking to be put on the list. So that will keep you abreast with what's going on within our industry. Our email address to go is arbic@honeybee.org.au, and the website is at www.honeybee.org.au. So I encourage you to get that newsletter. As I say, it'll cost you nothing, comes electronically, comes out once a month, and you will keep up to date with what's going on with our industry. So I think that covers the main issues that we have with ARBIC and what we do. So I thank you for the opportunity there. It'll be a bit hard to ask questions, but thank you for the opportunity to bring it there. If you do have any questions, you can contact me directly or contact our CEO, Helen Goodall, at the ARBIC address there, and we'll only be too pleased to answer any questions or give you any help that you require. So thank you very much.
Industry overview and strategic plan update from the New South Wales APRIS Association and their President, Steve Cunill.
Hi, my name's Steve Cunill and I'm the President of the New South Wales APRIS Association. I'd like to welcome you to the New South Wales APRIS Association presentation for the Tocal Field Day, which is Australia's longest running beekeeping field day, now in its 42nd year. The New South Wales APRIS Association is the state peak body for commercial APRIS. The New South Wales APRIS Association is committed to ensuring the future of the beekeeping industry, and the Executive Council represents its members in liaison with government, media and the general community. The New South Wales beekeeping industry overview. New South Wales is the nation's leader in production of honey and the ownership of hives that account for 40 to 45% of the national honey crop. New South Wales beekeepers contribute $129 million in national gross value of honey and associated bee products at the farm gate, and $36 million annually to the New South Wales economy from the value of honey and associated bee products. Beekeepers operate with a changing climate characterised by extreme events such as floods, bushfires and droughts, and changes in the economic and social environment that greatly impact the industry's production of honey and a vital role in pollination. The New South Wales Apiarist Association provides a means for the commercial apiarists of New South Wales to be represented through a common organisation, representing a majority of the state's 1,066 commercial beekeepers across 9 branches, has provided over a century of service to its members. New South Wales provides the greatest number of commercial pollination hives nationally. A new strategic plan has been drafted and is expected to be a foundation document to aid in charting the course of the New South Wales AA and overcoming the challenges of New South Wales beekeeping industry. So we come up with a strategic plan, 2021 to 2026, a 5-year plan. It was workshopped back in February with members from every New South Wales AA branch. The diverse background of all the workshop attendees gives this plan validity to represent the priorities of the New South Wales AA members, regardless of the scale of their bee operation. It's going to be a steering document that informs the members' priorities and actions of the executive. And it's going to help the New South Wales AA move forward as agriculture and the landscape around us changes. So during this strategic plan workshop, 7 priorities were identified. So we come up with resources, communication, biosecurity, New South Wales AA and industry, pollination, research and development and training. So resources, we require increase the access to native forested areas currently unavailable to industry. We need to increase the planting of bee-suitable plant species such as trees, crops and shrubs on farmland to benefit honeybees and farmers. We need to lobby to allow the replacement of infrastructure to enable access to floral resources. Communication. It was identified that connecting with New South Wales AA members, commercial and amateur beekeepers needed to be improved. We need to educate and engage with the New South Wales community and need to connect with the consumer to buy Australian products. Biosecurity. There needs to be a push for better beekeeping practices. Increase compliance is required to decrease the AFB, and control and disease and educate beekeepers in enforcing compliance while supporting research. Education to minimise exposure to AFB, chalk brood and varroa in the event that it arrives on our shores. New South Wales and industry. We need to improve members' understanding of the New South Wales AA. Incentives possibly for new entrants. Investigate synergies by combining activities and develop a media campaign about the benefits of beekeeping. Pollination, a very important topic. So we go back to the number 1 item, we need resources before pollination. As more hives become required for pollination, we need these resources to be able to breed up strong bees to fulfil these pollination contracts. We need to campaign against the use of pesticides and insecticides that affect the health and vigour of New South Wales honeybees. And very importantly, we need varroa preparedness training so that in the event that it does arrive on our shores, beekeepers will be prepared and able to get through. The aim is to have 90% of beekeepers trained in varroa. Research and development is required to add value to the industry, improve beekeepers' business prospects, and improve work time effort, future-proofing the New South Wales apiary industry and keep beekeepers in business. Scope out possible research and development areas that will add value to the honeybee industry. Another item was a development and training program. Increase industry participants, branch training, and promote good governance. So topics discussed were succession planning, pest and disease training, governance training, awareness of age distribution among commercial beekeepers for government statistics, and transfer of skills through mentoring and training. So they're the topics that were discussed with our strategic plan, and this plan will become an agenda item for our future executive meetings, so the executive can discuss each item and plan the way forward over the next 5 years to improve each of these topics. So we ask you all to secure your industry's future by joining the New South Wales AA. It's a great way to meet other beekeepers, support beekeepers in all regions of New South Wales, and help and maintain access to essential floral resources. So you can look us up on the internet and also our email address, info@newsouthwalesaa.com.au, or by ringing our secretary, Robin Lewis, directly, and she will help you through the steps to becoming a New South Wales AA member. Thank you.
Our next speaker is Dr. Shumi Paul Mukhopadhyay, Sensory and Consumer Science Researcher for the New South Wales DPI. She'll be talking to us today about honey and honey tasting and all the amazing flavours in honey.
Good afternoon, everyone, and welcome to the 2021 Tocal Beekeepers Field Day. Thank you so much for having me today. My name is Dr. Shumi Paul Mukhopadhyay. I work with New South Wales Department of Primary Industry as a sensory and consumer research scientist. And today I'm going to discuss with you a little bit in a virtual world, the beautiful sensory world of honey. I would love to actually come and discuss with you in person, but I think under the circumstances, this is the best way to talk to all of you. And thanks again for Tocal College, especially Ms. Kelly Lees, for inviting me today. We all know the feeling and happiness of tasting honey, isn't it? We know when you have a really good honey and the smile that you have on your face. You can have honey in different ways, but that particular feeling, that happiness, that satisfaction is just like this beautiful video here, like the Winnie the Pooh, the happiness that you can see on his face. I think that is the kind of happiness that we are talking about. Today, when we are talking about the consumer of 2021, there's a lot of changes that have happened over the last few years. Today's product development from any product perspective is not just based on what the producers are thinking, what the farmers are growing. It's also depending on what consumers are actually looking for. So this consumer-oriented research and product development is very, very important in today's market. Gone are the days when you just go to your supermarket and just buy the things that are available there. We have so many different options nowadays. We can buy online, we can buy various products from different parts of the world. So it is just not that we are buying it from Australia, sitting in Australia, but we can buy it from anywhere in the world online. So you can see there's a big difference that are happening, and that's the reason understanding your consumer and what consumers want is so important. Today's consumer is all about provenance. Me as a consumer, I also want to know where my food is coming from. They follow food trends. We are more educated in the sense that we know what we are looking for from our food. The consumers are more health and brand conscious, and why not? The COVID shows us that a good food, which is healthy and nutritious, are really, really important. Consumers are environmentally conscious too, so we really want to know how the producers are producing their product, the packaging they're using, how much it is going to cause, the landfill. We are technologically savvy, so we really aware about the food and the food safety. But most importantly, I think we are also clear about the sensory attributes. And please don't worry about what is sensory attributes. I'm going to explain that in the next couple of slides. But we really want to know and are aware about, what we want from our food. We want our food to be tasty, very much nutritious, but also, different types of food that giving us different types of sensory experience. So this particular slide is very close to my heart because you can see in one slide, you can see the red wine, there's olive oil in the middle, and then there is honey. But one of the things is very common, even if those three foods are so different, that sensory assessment and judging are equally important for honey, wine, and olive oil. And when we are talking about sensory assessment, it is just not only important for making sure that the products are tasty, but actually sometimes the sensory assessment and judging are important for giving these products kind of medals to win in a show. When we are talking about honey, we obviously, probably you are all aware that for honey, we need to do some chemical analysis to make sure that all the nutrients, all the other properties are actually according to the standard. But sensory assessment is also very important to know how the honey tastes, the smell, the whole flavor profile. So when you are obviously probably wondering why I'm talking about sensory evaluation, what it is actually. So sensory evaluation is a scientific discipline. It's used to evoke, measure, analyze, and interpret. Very important, these four words. Reactions to those characteristics of food and material as they are perceived by the senses of our sight, smell, taste, touch, and hearing. I'll elaborate on this big definition in the next slide. But in a very nutshell, in a layman's word, it is actually the way we perceive, the way we use our eyes, our ears, our nose, and the everyday from getting from getting up from your bed in the morning to the time that you go back to sleep. We just being overwhelmed and always being bombarded with so many um, different experiences. You just go for a walk and then you start smelling, one of the restaurant is baking pizza, or it is making some really nice Thai food. Your nose tells you where the smell is coming from. Your eyes help you to actually, when you're going to the supermarket, to all the beautiful colors, you actually go and touch different types of food if they are permissible to touch. And then sometimes to check the freshness of the product, you sometimes snap like the beans or like the okras. So definitely this particular definition is an inclusive effort by IFT, that is Institute of Food Technologists, in 1975 to make sure all the different types of food items are incorporated in this particular definition. So the understanding behind the human sensory function is so important because it gives us that whole experience about how our eyes, our all the different sense organs actually help us to enjoy that life experience about different foods. So not only from the eyes that actually help us to understand the appearance, the shape, color, and consistency, to the taste, all the five different tastes, that sweetness, sourness, bitterness, saltiness, the savory of the food items, by touching different things, you just actually get a very rich experience of what the food is going to offer to you. So when we're talking about the color distribution, you can see I have put this beautiful slide of honey, and you can see the variety. Can you imagine like how many different types of honey that are available in around us? And all the different types of honey, there's a color is one of the things that definitely attracts our eyes. And starting from a very dark color honey to a light color honey or the creamed honey, it just gives us an understanding of what we are going to expect in the aroma and the flavor, isn't it? So this is just a slide to show in one of the honey color chart, and you can imagine, the diversity of the color that you can encounter in a bottle of honey. So it can start from, the water white on the top to dark amber, and there's such a big distribution of color. So based on the type of honey that you want to produce, or it actually being preferred by the consumer, you can just imagine the diversity and the variety that you have in your repertoire to offer to your consumers. And obviously, the color and taste of honey is due to its floral source. So you'd be really the environmental condition where the plants are growing can have quite an effect on the aroma and flavor of honey. And sometimes different, the same, some of the honeys are taste different. Based on where they're where you are procuring them from, and sometimes it doesn't matter, it just tastes the same in anywhere in the world. So there are lots of things in the actual honey that are very complex based on the agroclimatic condition where the floral source is from. And after the eyes, obviously, the first thing that help us is actually our nose, because you can see the sense of smell, which is called olfaction. It actually tells us, how volatile the food is. So sometimes cheese, sometimes even if some really different types of honey has a very typical smell. When you open the bottle, if you smell it, you immediately know what kind of honey you are testing. And that's really good because it gives you an understanding of not only the source of where the honey is from, the floral source, but also that makes you ready for the experience of the flavor or the taste that you are going to encounter. So our olfactory receptors are actually present in the epithelium of our nose. So inside it's just a very like a hair-like, very fine hair-like cilia that actually have those receptors, and it can detect specific chemicals. So for any particular food to have a really strong smell, it needs to have a lot of volatile molecules so that it can actually easily transfer from the food when you are actually smelling it through your nose. And you can see that it actually travels through your orthonasal, so your front of the nose, actually to go and meet in the back of your throat. And when you're smelling, because we don't actually do it so slowly, we do it simultaneously, isn't it? You are smelling the coffee, but you're also having a sip. So by the time you are smelling and you are actually having the sip, the retronasally, it's actually meeting at the back of your throat. So where you are actually getting your flavor. So obviously, if you can't smell properly, sometimes you can't taste the food. And this is so true, isn't it? Like, when you are having like a flu-like symptom or when your nose are blocked, sometimes it is very difficult to taste the food. So you can imagine the importance of our olfactory receptors, especially our nose. So having a good nose is very important. And then, as I have mentioned before, the flavor includes the taste on our taste buds, the odor or the smell that is actually perceived through our nose, and then all the tactile sensation that can be felt inside your palate. And the taste receptors, which are very important for us, the taste buds that we call, they're all located on our tongue. Okay, so inside the mouth, on our tongue, and the taste buds are very important because they're replaced every 10 days. And so sometimes the way you are growing up, by the time we are very old, the intensity or the rate of regeneration of those taste buds actually started slowing down. So that means the same kind of food that you are so used to in your younger years will not taste the same when we are really old. And that means that sometimes we need more salt or more flavor in the same food to have the same taste experience when we are older. Um, so that's very important to understand how our human, physiology, how our human senses actually help us to perceive different types of food and enjoy the experience. So what I have mentioned already, that the interaction of the taste and smell is actually giving you the flavor. So flavor is a combination of so many different things, it's just not the taste, just not the smell. It's actually the taste, smell, and then the tactile sensation that you can actually feel. So, sometimes you're feeling like your mouth inside is getting very dry, it's getting puckered. So that's the kind of tactile sensation that I'm talking about. With honey, most of the time you don't always have a bad tactile sensation, but sometimes if it's the honey is too sweet and if you are not used to sweet, something that can give you very different tactile experience. that not all the people actually get that. So now coming to the type of honey, the small picture actually shows the diversity. You can see from the creamed honey to honey with the different honeycomb, the dark color honey. There is so many types of honey available in the supermarket, in your farmers market, with your local beekeepers. And I'm just putting here one very good, very important, kind of a book. What I can say, it's not just a book, it's just the whole repository of the knowledge about the different honey and their the flora that are being already being produced and published by our very close Tocal College in New South Wales DPI. And I'm sure a lot of you probably have already heard about this particular book and probably have it in your library. So this book is something that actually gives a really good understanding of how many types of flora, what is the relationship between flora and the honey flavor, and so much more that is available inside this book. So this is something that probably is a kind of a must book that we should have, as a beekeeper or as a honey researcher. So when I'm talking about the sensory attributes of honey, now you understand sensory means all 5 different senses that actually gives us the whole experience. So coming from the visual attributes, this slide and the next slide will actually show you in a very precise way that what are the different attributes for honey that we should be thinking about in terms of its sensory experience. So coming from the visual attributes like the color intensity, the crystallization, if the honey is very fluid when you are actually trying to pour it, or if it is very viscous that you really need a spoon and getting it difficult to take the honey out. So that gives it the viscosity if it is too fluid or too thick. And then after that, obviously, the aroma that comes in. So, what kind of aroma you are smelling, if it is floral, if it has a kind of a fruity characteristics that you can smell, if it has, any chemical smell or any animal. So there are some of these attributes are considered positive for the honey. So you should have them. That will actually give you a very, that happy perspective of having honey. But some of these characteristics or attributes like the animal or the chemical, so that can give you an idea if the honey has any defect, or if the honey is not in its best form. So that's the reason I think these are very important when we are thinking about or judging different types of honey. So after obviously the appearance and aroma, then it comes from the taste and mouthfeel. And this mouthfeel here that I'm talking about is the tactile sensation, that mouthfeel, not the taste. So obviously the sweetness, the sourness, saltiness, bitterness, all of these are some way related to the different types of honey. And the persistence and astringency are the mouthfeel property or the tactile sensation that I was talking about before. And the persistence is actually how it depends on the time. And after you have the honey and you swallowed the honey from the spoon, how long you are still able to actually perceive it inside your mouth, and you feel like it is still there. That kind of sensation is not a taste; it's a mouthfeel sensation. And the astringency is all related to it's most related to your tea, sometimes coffee, sometimes wine, that astringent sensation that it creates inside your palate. And then comes the texture attributes that are so important for honey, the adhesiveness. Obviously, how many times when you are having a spoonful of honey and then you feel like, oh, it is stuck inside my tooth, how to remove it? So that clinginess of the honey and then sticking to your teeth is not always one of the very the memorable experience, but I think that is also important for honey. And then granularity, that definitely tells us how crystalline the honey is, how much crystals are there. So hopefully you get an idea about how diverse based on these attributes a honey can be from one to other. This year, some of the researchers from Romania, they actually published a paper in January 2021. I have included the link in the bottom of the slide. if you want to know more about it. This research actually caught my eye because they really wanted to analyze the mint honey from a sensory perspective. So you can imagine it's just a particular type of a flora that we are talking about. It's just the mint, that particular very specific sensory attribute. And when you are actually then comparing the same mint honey with honey coming from acacia or summer flower or sunflower, so you can imagine the smell and the color. If you see, there are some differences that are happening here. Obviously, the consistency is not always the most determining factor in the difference between two honey, but obviously it makes a lot of difference in how the taste and smell come to you. But the color, smell, and taste can actually decide where your honey is coming from. So I just thought to include it to see, mint honey. That would be interesting to try, isn't it? I'm not sure how many of you have tried it. I haven't tried it here in Australia, but I would love to try this mint honey because I can't imagine having that minty menthol aroma with the sweetness of that honey. How how refreshing that would be. So hopefully sometime soon. So the next thing that happens, when I'm talking about honey and the sensory attributes, it would be really difficult not to mention this particular honey flavor wheel, which was developed from University of California, Davis. And this actually gives, just in a nutshell, it has more than almost 100 descriptors to describe honey from different type of floral source, its different attributes, and everything that you can think of that can be associated with honey. I must say that you will not be able to taste or perceive or smell all the different descriptors in one honey. So this has been done with developed with so many different honey from around the world to make sure that it actually encompasses all the diversity and variety of sensory attributes that honey can actually offer. And here I'm just trying to, little bit highlight some of the important one, the tree fruit. You can think about the tropical fruit like banana, guava, mango, melon, pineapple, the different type of floral source where the bees can go, jasmine, orange blossom, to chocolate, like, the mocha or cocoa, and then confectionery or caramel that can be also related with honey. Especially the butterscotch toffee or the molasses or the vanilla. So just imagine that pleasure, that happiness that I have shown you in the second slide. I'm pretty sure that's the reason, you know, the we all love honey. We all love honey in its different, way, and the different way we would like to consume it. And it has so many different applications. Again, this one is one of the way to show one of the example of the honey flavor and aroma chart. So this is available also, and then you can actually use this as one of the way to ensure that the kind of honey that you are having in your, as a beekeeper. So you can actually see what are the different characteristics or attributes your honey have, and compare and check, the types and what you can actually perceive from these aroma charts. Obviously, there are so many honey testing workshops that are happening. I personally judge this year in the 2021 inaugural New South Wales Apiarist Association honey judging, and I'll share some of the photos and pictures from there. But there are some basic tips that I have actually enclosed here. So obviously you need to smell the honey before testing. You need to check the color. Obviously honey is a sticky one, so a small amount goes a long way. So make sure that you are not bombarding your senses with a lot of amount of honey, and then you make sure you let it spread out inside your mouth. And then obviously you try them warm and or cold based on based on the usage or the application. So this is one of the, this is not the final one. This is one of the kind of a testing sheet that is available. I found it in the internet, but based on your the kind of work you do, or based on the kind of honey that you are growing, you can actually have a different type of worksheet to go through different sensory attributes. So this is just like a way to understand how individual consumer or any panel members or the judges view or perceive same type of honey. So we can do this with so many different people and then get an idea about a particular honey based on your individual preferences. So it's a beautiful way to taste honey. So understanding honey sensory descriptors are very, very important, as you have seen over the last 20 minutes, that there are so much diversity in the sensory attributes of honey. So you can't just taste one honey and then determine, okay, this is the best honey that I have tasted. There is so much to taste from, and then there's so many positive sensory attributes to experience. And I think that's the reason sometimes as a sensory researcher, I think we need to have like a consistent national framework of training to make sure that, as a judge, as a panel member, or as a consumer, we need to know what types of sensory attributes that Australian honey can offer us. Definitely a lot of work has been done, but I think more work needs to be taken in the future to understand the diversity and the variety of honey in Australia. And why not? Australian honey is just so amazing to taste. I haven't been able to taste so many other type of honey apart from some honey from New Zealand. But most of the honeys that I have tasted before coming to Australia are from Australia. So I think it is very important that we also support our local beekeepers, and that's amazing to taste different honey. Sometimes the local beekeepers and the honey that you get from your from your farmers market, it's just amazing to taste, and you have so much trust on them, isn't it? Because you know the person, and it just brings out that the best quality of honey that you can get. And obviously supermarkets also offer so much, and nowadays with the online platform, it is so easy and important. Once you probably have done a test testing somewhere, and then you just know that this is the honey that I want to buy, and then you can just go online and buy. And this actually shows that how much consumers nowadays can access different types of honey, not only honey but other food. But in terms of honey perspective, it is so easy nowadays to access a very honey from Western Australia sitting in New South Wales, honey from Tasmania sitting in New South Wales. You don't have to actually go to Western Australia to buy from there. So that gives us that builds that experience, that builds the knowledge of types of honey that you can try and enjoy that flavor and that purity, in the honey that Australia has to offer. So as I mentioned, and I promised you that this year I was very privileged to be invited by New South Wales Apiarist Association for the inaugural honey show in Tamworth in May, and there are just amazing amazing classes of honey that have been been judged, and it just shows in a small way that so much diversity is already available. And just imagine if you know everything about it, and how great your palate would be if you can experience all the different types. So this particular slide shows the things that I need to do to judge the honey, looking at the color, making sure it smells, what kind of smell that I'm actually getting when I'm smelling the honey. Then obviously comes the taste, and then writing down all my feedback as a judge. And then these are the diversity. You can imagine, you can see in the top left, this is just such a beautiful way to show a collection of different apiary products, not only honey but mead and beeswax and the candles, and so many different things that you can think as a product from honey. And then you can see that the creamed honey and the diversity here in the bottom left, and then obviously dark honey, the non-eucalypt honey, and just the range and I was just so privileged and honored to actually taste and try so many different things, and there are just so many prizes for our beekeepers for producing such an amazing range of honey. And the last but not the least, this would not have been possible if I would not have been invited here today from Kelly. So I'd really like to thank immensely to Kelly Lees and also Natasha Hay and our amazing Tocal team for organizing such a beautiful event and making us all part of it, even virtually. Um, it would have been so amazing to see you all, and have a face-to-face discussion and probably some honey testing. But unfortunately, I think it is still good that we are connected, even virtually, and actually having this field day going on. And there are amazing speakers, and I hope that you are enjoying the day as I'm enjoying presenting today. And lastly, my talk will not be possible without the support from New South Wales Department of Primary Industry, and my colleagues, and to all of you, my attentive audience, for listening to me. So thank you so much. My email address is attached. I have included it on the first slide. So if you have any questions or want to have a chat, feel free to let me know. So thank you so much for having me, and I hope you have an amazing field day today. Thank you.
A combined presentation now from the Elizabeth Macarthur Agricultural Institute, Belinda O'Rourke and Kushu Gandhi from the New South Wales DPI, technical officers for bee diseases, talking about lab techniques, bee disease diagnostics and research projects that are going on at the EMAI.
Hello everyone, my name's Belinda O'Rourke and I'm a Technical Officer in the Microbiology Lab at Elizabeth Macarthur Agricultural Institute. Today I'm here to talk to you a little bit about bee diseases and the laboratory diagnostics that we work on. The Elizabeth Macarthur Agricultural Institute was established in 1990 and it's situated near Campbelltown in New South Wales, and it's a world-renowned premier biosecurity facility and enhances food and fibre production and helps protect the environment. It's run by the New South Wales Government, by the New South Wales Department of Planning, Industry and Environment, and its focus is on research, veterinary diagnostics, plant health, community education and farming. And we have a number of labs on site, including virology, serology, parasitology, microbiology, genetics, plant and soil health laboratories, and importantly for today, we have 2 labs working on bee disease diagnostics and research, and they are the virology and microbiology labs. Today, I'm going to be mostly focusing on the work in microbiology laboratory, which is the laboratory that I work in. And mainly we are a veterinary pathology diagnostics testing lab, and we usually test livestock and bees. But we do also get wildlife and domestic animals in, as well as exotic animals from zoos. So we have quite a range of tests that we run. We have a team of 8, plus we have support staff. And our bee work includes microscopy for AFB and EFB detection, Nosema detection, we do honey culture for AFB, we do OTC testing, and we have a small section running some research on our bee work. Here's a quick look back at history, and the first records of beekeeping were about 9,000 years ago, and bees were housed in pottery vessels. This picture here is of Egyptian art showing beekeeping about 4,500 years ago, and I think that's pretty cool. So if we jump forward a couple of thousand years to Aristotle, he was the first to describe diseases and disorders in honeybees, and his description was a lassitude on the part of bees and a malodorous of the hive, and that just means weak, lazy bees and a foul smell of the hive. And although the descriptions could not identify the disorders with any great certainty, it was the first time that disease was described in honeybees. If we jump forward again to 1771, honeybee brood disease was described by Adam Chirac, and he characterised it by a foul smell, and he was the man who coined the term foul brood. Another 100 years later, and it was finally determined that there were two different types of foul brood. One was mild and curable, and one was malignant and incurable, and both were called foul brood. It was in 1906 that G. White first identified Bacillus larvae, which is now been renamed as Bacillus larvae, as the cause of American foul brood. And it was at this stage that AFB and EFB were formally recognised as separate diseases. But it wasn't until 1919 that he discovered that EFB was caused by Bacillus pluton, which is now called Melissococcus plutonius, and it was found in many European countries and in America. It was in this era, in the early 1900s, that other diseases, such as nosema and viral diseases of honeybees, were beginning to be identified. And today, bees are known to suffer from over 30 infectious diseases and parasites. Now, to bring it home a little bit closer to us, this is the timeline of detection of some of the diseases and pests in honeybees in New South Wales. So in 1976, AFB and EFB were detected in New South Wales. In 1992, chalk brood and Nosema apis were detected. In 2002, small hive beetle was detected. And in 2007, Nosema ceranae was detected in New South Wales. Now, these are the bacteria and pests and other diseases that we work on in the microbiology laboratory, but between 1987 and 2015, a whole host of viral bee diseases was also detected. So I'm just going to focus in a little bit on a couple of diseases that we do a lot of diagnostic work on for New South Wales and other states and territories. AFB is a fatal disease of honeybee brood, the larvae and the pupae. It usually kills beehives, and it's caused by Pinobacillus larvae. Unfortunately, it is the most destructive and widespread of the honeybee brood diseases. AFB infection is caused by the spores of the bacteria, and most of those spores are removed from the hive by adult bees. It is, however, the youngest of the larvae that are most susceptible to infection by the spores, and it only takes about 10 spores to infect a larvae that's less than 24 hours old. As they age, they require more spores to infect them, so a larvae 24 to 36 hours old requires 500 to 1,000 spores, and once they're 48 hours or more old, it takes millions of spores to infect them. So really it's those less than 24-hour-old larvae that are most susceptible to infection by the spores and therefore catching the AFB disease. And there's a couple of ways that AFB can spread between hives, and it's often an interchange of contaminated equipment between infected hives and non-infected hives. Can occur by bees robbing honey from diseased hives and taking it back to healthy hives, and there's a low risk from drifting bees. And unfortunately, there's no treatment for American foul brood, and the only options are eradication of the whole system, which is destruction of the hives by burning or by gamma radiation. Here we have examples of healthy brood on the left and diseased brood comb on the right. When you're looking for disease in the comb, you're looking for irregular brood patterns, a mixture of capped and uncapped cells. Individual cells might be sunken, darker in colour, greasy looking. There could be perforations in the caps as well. And you can see on the right here on the picture in the middle, we have the dried out scale in here at the bottom of the cells, and that's at later stages of infection. And then down the bottom, on the bottom slide, we have the brown goopy ropiness test that we look for in AFB. And this is the sample that you would take and send in to us on a smear, or you can collect larvae, dead larvae, and spread them on a smear as well. Moving on to EFB, or European foul brood, it is also a brood disease which usually is not fatal. It is widespread and is endemic to all states and territories of the eastern of Australia. It has not yet been discovered in West Australia. It's caused by the bacterium Melissococcus plutoneus, and it has a secondary invader caused by a bacteria Pinobacillus alvei, not to be confused with Pinobacillus larvae, which is the AFB bacteria. So here we have two examples of brood comb that's infected with European foul brood, or Melissococcus plutoneus and Pinobacillus alvei. It's characterized by patchy brood comb, uncapped brood cells, and the dead and dying larvae will often have this brownish yellowish tinge to it, which you can see in this slide here with this and this larvae both having that tinge to it. Once the larvae die, and they also become molten or brown and gloopy, and there's a distinct smell with European foul brood, and often when it comes into the lab we can smell that before we can see anything. The incidence of EFB is generally higher when the hive is under stress, and that can be caused by climate conditions, excessive rain, cool climate, movement of the hive, poor nutrition, and heavy infections of EFB will infect a large percentage of the brood comb, a weakening of the colony over time, and possibly leading to the death of the colony. However, it's not as fatal as AFB. Now, treatment of European foul brood, there is an option, and that is treatment with oxytetracycline, and it is a prescription antibiotic, but it is the only treatment approved in Australia at this time. So a discussion with DPI on treatment of that is always recommended. So nocemosis is a disease of adult honeybees, and it's a silent killer of them. It's caused by microsporidium, which are tiny parasites that live in the gut of the adult bees, and the two that are identified are Nosema apis and Nosema ceranae. And identifying it in the hive is difficult, but in general, infected bees live only about half as long as non-infected bees. Queens are superseded within 2 to 8 weeks of becoming infected. It usually occurs in late winter, early spring. You'll notice a dwindling number of bees, and a decrease in honey production, decrease in brood production due to the queen being less productive, and it can kill off hives. Chalk brood is another disease that we look for in the lab, and it's the only significant fungal disease of honeybee brood, and it's caused by Ascosphaera apis, and identification is via the brood comb. So if you're going to send something to us, it's brood comb that we need to see with the mummies, and that is the larvae that are covered in the fungal growth, which is down here in these ones here, and later they dry out and become grey or white or black chalky, which is this one here. So these are what we call mummies, and that's what we're looking for when you send them in to us. So as I said, testing in our microbiology lab, it includes microscopy when we're looking for the spores of Pinobacillus larvae. We're looking for Melissococcus plutoneus down the microscope, the spores of Pinobacillus alvei, which is the secondary invader of EFB. We do microscopy for Nosema species. We do culture on honey for Pinobacillus larvae. We do check comb for chalk brood. We also have developed testing for the oxytetracycline in hive products. So we have a test for that now. And like I said, we have some research on the go, which my colleague Kushbu will be talking about later. Now, this is straight from our website, the State Veterinary Diagnostics Laboratory website. And on here you can see that these are the samples that we require to run our testing. And on here we can see that for the honey we've got a minimum of 100 mils. The website at the moment states 75 mils, but we are updating that to be 100 mils, and you'll see in a moment why we're doing that. So I just wanted to give you a quick look at what it is we actually do with your samples once we get them and how we do identify the different diseases, mostly focusing on AFB and EFB and a little bit on Nosema. So these slides you can see in this picture are what are sent to us, and they have the larvae on the slide, so you can put up to 3 larvae on each slide, smush them on and package it up carefully. If you've got that ropiness or you've taken some sample from a brood comb, you can send it in on any hard surface and we will sort out making a slide from that, preferably slides, but if they're too hard to get a hold of, you can always send it in on anything. And we've had mirrors, we've had coffee cup lids, we've had all sorts of submissions sent in to us, and we will always try and come up with an answer as best we can. So what we do with those slides is we will heat fix the sample to the slide, and then we will stain it with this pink stain here, and that just brings up the spores and bacteria for us to be able to identify. And this is one of our ex-colleagues. This is in the lab, and he's looking at some bee slides under the microscope. And the picture on the right is generally what you can see. It's about the size that we come across. And in the next slide, you can see here that these little spores here are the ones that we're looking for. And there's thousands of them, millions of them. And when we identify these, it's AFB positive. In this page, you can see EFB. Now we treat the slides the same, we stain them up, we look at them under the microscope at 1,000 times, and you can see here that we have the Melissococcus plutonius in this slide. Then they're tiny little lemon-shaped circles that we can see, and that is EFB positive too. On the right slide, you can see we have lots of spores. Now these spores here, these are the Paenobacillus alvei, or the secondary invader of European foulbrood. In this slide here, we can also just see up here, and in a few different spots, are some leftover Melissococcus plutonius. So those 2 slides there become EFB positive. So when we requested to culture for AFB or Paenobacillus larvae, what we're looking for are the live spores in a sample. And we do this by running it through a process, and we selectively culture on special plates which knock out other bacteria that would stop us from identifying the Paenobacillus larvae. And when you send us a sample, if your sample turns out to be positive, your results will come out with an explanation on the percentage likelihood of AFB disease in one or more of the hives that honey was collected for. Now this percentage is result, and it's been determined from research when developing the procedure, and that's the reason why we request the minimum quantity to run it, because our test has been developed with using 75 mils of honey. So if we have less than that, our results don't mean it quite as much and aren't validated. And that's why we request 100 mils, so we've got plenty to use. And this is one of our current lab staff running our honey culture procedure. And what we do is we get our honey in that you guys send us, and we warm it up till it's runny, and then we mix it in these bottles up here with a buffer liquid, and we shake it to emulsify it, and then we spin that for a long time, and we spin it down so that all the spores collect in the very bottom of these tubes here, and from that we then heat that sample that's right down the bottom that's hopefully got either no spores or all the spores from that sample in the bottom of that. We heat it up and we place it onto these plates up the back here, and they are our selective plates which help us knock out other bacteria and help grow the Paenobacillus larvae. And this plate up the top here is an example of a positive growth for Pinobacillus larvae. Now this is a heavy growth. This is a control organism that we have in the lab that we use to validate our tests and our media that we make, the plates here. And that's what it looks like. And colony morphology, what the bacteria actually looks like, and some other factors are what we use to identify the Pinobacillus larvae. And in the last few years, we have acquired a MALDI-TOF machine, which is the picture in the bottom right here. And that machine identifies bacteria. So we place a sample of off the culture plate into the MALDI-TOF machine, and that breaks it up into proteins and gives us a profile and gives us an identification of Pinobacillus larvae or whatever other bacteria we may have cultured. And it just gives us additional confidence in a positive result. This page here is our Nosema testing procedure. So for Nosema testing, we need 10 to 25 adult bees. Now you can send them into us like this one in a container. They're already dead. Or we like them also preserved in some alcohol. The adult bees are ground up in the machine up the top here and this second picture. And what we're trying to do is get the Nosema parasite out of the gut of the bee. So we crunch it up and we place a tiny amount, only 3 microliters onto a slide, and then we look at that under the microscope as well. And those parasites, like you can see in this picture, they light up under dark field microscopy, so we can identify them through that. And here I just wanted to give everyone a bit of an idea on how to get your samples to us. I know it can be a bit tricky to find on the website, so I've included the link up the top here for anybody who needs it, or you can just search in your search bar for the State Veterinary Diagnostics Laboratories, and that will bring up the Department of Primary Industries here, and you can click on that page. If you click on this test list pricing over here, that will take you to a page over here, and that second page up here is where you can click on all the different tests. But as beekeepers and honey producers, if we click on one of these 3 here, the BMIC, American Foul Brood and European Foul Brood microscopy, or the culture for the honey, if you click on those, it will bring you to another page. And then from that, you can find this further identification or further information sheet down the bottom here, and that will lead you to this form. Now this is the bee diagnostics form. If you fill that in and send it to us, that gives us as much background as you can. It gives us an idea of what is happening in your hives or with your bees, and we can have an idea of what we're looking for. Any further information is on the next slide. And on this one, it's the same process, but this one gives you a guide for collecting samples to send into us. So you can get a DPI prime fact sheet, which helps to show you how to collect samples to send into us. So it's the same procedure as getting into the submission form that we send into us. You click on the test list and pricing, and then one of the 3 B tests, and you can go down and you get to specimen requirements, and you can click on how to collect samples and prepare samples, and that takes you to the prime facts sheet. So they're all helpful tools in order to get your sample to us. If filling in an official form is impractical because you're out in the field, or you can't print it off, or it's just not working, hand write us a form, give us the information, give us some background. It all helps in our diagnosis of your bees. And I just wanted to talk through a few things that come into the lab when we're trying to run our diagnosis on them. And you can see in this left picture, we've got 3 different types of samples that get submitted to us. We've got your honey, we've got your smears, and then the bees. These are very good examples of sending us samples, and we will take them in just about any form. If your smears smash on the way to us, we still work very hard to make new smears from the samples that you've sent us. The only time we can't read a smear is if it's got honey or wax on it. It interferes with our microscopy and our staining process, so we can't see anything through honey because we're looking at 1,000 times and through oil. It makes it very difficult for us, so we ask that we avoid as much honey or wax items on those. Up the right here is some honey. We also ask that honey is sent in as clean as possible. We understand that it's not always possible to get everything out of it, and that's fine, we can cope with that. But when it's got a lot of wax or comb and other materials in it, it interferes with that process when we're spinning the honey down, and we can't get a proper sample out of it to test. The other example here is just a pot that's just a bit too small. If you're going to send those in, that's fine. We just need 2 of them, but we need to know that they're the same sample. Otherwise, we will contact you and ask you the question, just in case that they're separate samples or anything like that. So I'd just like to say thank you to Michael Hornitsky, who is our consultant and bee guru here, and he's been a great source of information for me, and he supplied a lot of these images that I've used today. All my team at EMAI in the microbiology lab have been great support, and the management of EMAI. And we look forward to seeing all your bee, honey and slide samples, and we're here to help, so please contact us and let us know if there's anything we can do for you. Bye.
Hello everyone, my name is Kushbu Gandhi, working as a technical officer in microbiology department at Elizabeth MacArthur Agricultural Institute. Thank you so much, Belinda. So far we have all come to know about the bee disease diagnostic world at EMAI. Let's move to the second phase, which is bee research at Elizabeth MacArthur Agricultural Institute. Today, I'll be talk about the 3 different research topics that has been carried out in last 3 years at EMAI. Very first one, has Penibacillus larvae, the curse of American foulbrood, had developed the resistance to the oxytetracycline in New South Wales? My second topic is about the introduction of the newly developed test at EMAI, which can detect OTC in powders collected from AFB-treated beehives. And my third and the last, very important, to develop a technique to trace the bacterial disease of honeybees by using their genomic sequences to control AFB infections and outbreaks. Let's begin with my first topic. Now we are all aware of the use of the antibiotics for the treatment of AFB. In 1940s, the sulfonamide were the first antibiotic used for the treatment of AFB, but Penibacillus larvae developed resistance in the USA. In 1950s, the use of the tetracycline commenced. However, Penibacillus larvae has also developed the resistance in some countries, including Argentina, Canada, and USA. As we are all aware of the use of the oxytetracycline is illegal in mainland Australia for the treatment of AFB, although there is anecdotal evidence that indicates that OTC is being used for the treatment of AFB. So why is it illegal? Let's discuss the disadvantages associated with the use of the antibiotic treatments for AFB. The first one, when you apply the oxytetracycline to the beehive securely mixed with the sugar or other substances, initially for the couple of months, there will be no sign of disease, but the disease will start to return back between 3 to 14 months after the treatment. Few years back, Japan imported Australian honeys, but they all sent back due to the oxytetracycline residues in the honey. So it is very important to have a pure honey without any residues of antibiotics in it. And lastly, Penibacillus larvae has started to develop the resistance to oxytetracycline. To determine the state of the sensitivity in 2019, beekeeping industry requested us at EMAI to test oxytetracycline sensitivity of Penibacillus larvae in New South Wales. In 2005, the authors Wu et al. Published a research study, the Journal of Apicultural Research, where they have tested total 44 Penibacillus larvae isolates, and their study demonstrated that the Australian Penibacillus larvae isolates were sensitive to oxytetracycline. So we used the same techniques and the methodology in 2019 to find out whether the New South Wales isolates has developed any resistance against the oxytetracycline. The 2005 study indicated that the MIC minimum inhibitory concentrations to oxytetracycline ranged from 0.04 microgram per mil to 0.6 microgram per mil. To determine the antibiotic sensitivity in 2019, we decided to replicate the methods which they have used in 2005 study. We began to culture 2019 NSW diagnostics samples. They were either honey samples or the larval bee smears, and with these we instigated our project. We also use the same agar dilution method what they have used in their study in 2005. To find out the minimum inhibitory concentration of the Penibacillus larvae isolates to oxytetracycline, we have prepared a few different concentrations, including no OTC, where there is absolutely no oxytetracycline, then 0.04 microgram per mil of the concentration of oxytetracycline, then 0.1, 1 microgram per mil, 2 microgram per mil, and 4 microgram per mil. In our study, we have tested total 47 Penibacillus larvae isolates. In this picture over here, we can see we have used 3 different Penibacillus larvae isolates, which grew very well on the control plate, as well as on 0.4 microgram per mil, and as well as also on 0.1 microgram per mil, but did not grow on 1 microgram per mil. And therefore we can say the MIC minimum inhibitory concentration of these 3 isolates were 1 microgram per mil. Out of our 47 isolates, 35 did not grow on 0.04 microgram per mil. Therefore, we can say the minimum inhibitory concentration for those 35 isolates was 0.04 microgram per mil. In rest 12 isolates, the one isolate did not grow on 0.1 microgram per mil. Out of remaining 11 isolates, 8 did not grow on 1 microgram per mil, and last 3 stopped at 2 microgram per mil. In 2007, a research paper in veterinary microbiology reported that the Penibacillus larvae isolates can be considered to be susceptible to oxytetracycline when their minimum inhibitory concentrations are less than 4 microgram per mil, intermediate for MICs of 4 to 8 microgram per mil, and resistance when it is greater than 8 microgram per mil. And therefore, in our study, whatever we saw, we can say that all NSW isolate tested can be considered sensitive to oxytetracycline. Let's move to the second topic. As I mentioned before, there is some anecdotal evidence that indicates OTC is illegally used for the treatment of AFB in mainland Australia. So for the regulatory purpose, we, the laboratory at Elizabeth MacArthur Agricultural Institute, have introduced a new test to detect oxytetracycline in powders collected from beehives where the majority of AFB positive. This is a test kit what we have used to detect the presence of or the absence of oxytetracycline from the powder samples from the beehives. This is the test kit is normally used for the milk samples where they want to check the presence or the absence of the beta-lactamase and tetracycline from the milk. We modified this test kit to use for the powder samples collected from the beehives. This test kit is just like the normal dipstick method test kit or similar to the pregnancy test kit. The first picture is the instruction and the second picture on the right is what the test strip looks like. If the red line is visible, the sample is negative for beta-lactamase or the tetracycline. And when the red line is not visible, the tetracycline is present in the sample. Let's have a look at the results for the last 3 years. In 2019, we have tested a total 14 powder samples for the oxytetracycline and we found 11 positive and 3 negative samples. In 2020, out of 9 samples, we got 6 positive and 3 negative samples. This year so far, we have tested only 1 sample for the oxytetracycline and which turned as a negative. Based on these results and our study, it indicates that OTC is being used for the treatment of AFB in New South Wales. Let's move to our third research project. Outbreaks of AFB occurs frequently, but source of infection is often difficult to determine or in many cases may even go undiagnosed. So our aim was to develop a technique to trace AFB infections and its outbreaks. Now, we are all aware of the technology used to trace and control COVID-19 infections and outbreaks. In comparison to the other countries, Australia has been playing a very successful role in identifying the COVID-19 outbreaks throughout 2020 and 2021, which has prevented the high mortality rate seen in other countries. One important reason for this success is the ability to determine where the infected individuals acquired the virus. The technique used to trace COVID-19 infection is called genomic sequencing. This involves the analysis of DNA sequences, that is, the base molecules that make up the DNA of the bacteria or the organisms of interest. This genomic sequences technique is also used in tracing source of the food poisoning and the hospital diseases outbreaks. This genomic sequences would be also have an application in tracing our AFB sources. Let's discuss about the advantages of this GS technology. Comparison of genomic sequencing data from the AFB outbreaks would provide information to the link positive detections and identify strain clusters. These links and clusters could then be used to support the trace back and trace forward the activities by biosecurity compliance officers. When applied to the larger population, this can expose the transmission pathways and give biosecurity compliance officers powerful information to help to control the disease and its outbreaks. Additionally, an accessible online database where GS data could be uploaded and analyzed from multiple states, jurisdictions would allow AFB outbreaks to be more easily traced across the state borders. In this database, we have included the information relating to the bee samples, including submission number, that is our unique identity code for our laboratory. Then we have added the total samples received, means like we received like 3 combs, 4 smears, 5 honey samples like that. Then type of the sample. So our positive Bacillus larvae, either we picked from the smears or we picked from the honey or from the comb. And then sample number, then submitter's name, owner's details, property address, hive location, suburb, postcode, etc. EMAI is the diagnostic center for the bee disease diagnostics in New South Wales, including AFB diagnostics. We hold an extensive range of the Penibacillus larvae isolates. This includes isolates from the most Australian states and more recently isolates detected in Northern Territory. We have also got a collection of the freeze-dried isolates from 1982 to 1998. The main source of Penibacillus larvae isolates for this project were larval bee smears, brood combs, interstate honey samples, and roughly 200 historical freeze-dried isolates. The successful outcome of this project, we can identify more cases and the sources, and it can help to reduce the number of the infections and prevent the future outbreaks. Validated genomic sequencing tools and online databases will help link cases together across the Australia. Also gives us an ability to identify even minor variation between the species. In the beginning of 2020, New South Wales Department of Primary Industries at EMAI commenced this project with the collaboration with University of Technology Sydney. This project led by research scientist Dr. Daniel Bojema, bacteriologist Dr. Anya Deutscher, and the bee experts Dr. Michael Hornitsky at EMAI. Funding was obtained through the Australian Centre for Genomics Epidemiological Microbiology, a research centre with the funding with UTS and New South Wales DPI. Further funding is being sought to straighten this work and construct an online database to identify the linked AFB detection and aid AFB outbreak tracing. I would like to acknowledge our bacteriology team at Elizabeth MacArthur Agricultural Institute and Department of Primary Industries for all their support and the time. Thank you.
Introducing Elizabeth Frost, Technical Specialist Honeybees, New South Wales DPI, talking about queen bee breeding and the Plan B selection manual.
Hi everyone, my name is Elizabeth Frost and I work for New South Wales Department of Primary Industries based at Tocal Agricultural College. I work for Department of Primary Industries as a technical specialist for honeybees, and my topic today will be covering the AgriFutures managed National Honeybee Genetic Improvement Program, also known as Plan B. So what you're seeing here is the start of our exciting 2021-22 season. So I'm there on the left of your screen, just taking a back break after we've delivered our research hives to almond pollination with our research partner Olam, which is Australia's largest almond corporate farm. And horticulture industries are invested in honeybee genetic improvement program because of the honeybees' vital importance as a pollinator for their crop yield and for food security in Australia. So through this presentation, I'll be giving you a run through of Australia's National Honeybee Genetic Improvement Program, which we lovingly call Plan B. With the team, we've got a broad project team and funders, and the program is funded through a federal grant. So a federal grant in this program called Rural Research and Development for Profit. So those are paired with research programs that increase the profitability of Australia's rural industries, beekeeping being one vitally important one to Australia's food security through pollination services. So when honeybees are going to flowers, they're not only collecting nectar to make you honey, they're transferring pollen from one flower to the other, which is the plant's sex cells, fertilizing those flowers, and all conditions going right, producing a fruit, nut, vegetable, legume, oil seed, a lot of tasty things for man and beast. So we've got our program contributors and managers here, and I'm from Department of Primary Industries, neatly housed here at Tocal College, which is a registered training organization and a leader in development and delivery of the Certificate 3 in Beekeeping. So with our program, we'll go wide first. I'll zoom out and tell you a bit about it from this slide from my colleague, Dr. Nadine Chapman at Sydney Uni, and then we'll go into the specifics about what is the actual problem here. So the point of this program is to develop standardized methods for beekeepers of all scales. So those with few hives that might want to raise queens for themselves, those sideliners, or commercial, small scale commercial to large scale commercial that have some risk to their business related to queen bees, access, queen quality, their own production in their business and how queens affect that. So we've got a lot of different arms to this project, and where Department of Primary Industries and Tocal College is involved is around developing those standardized methods with Sydney Uni and with commercial beekeepers and sideliner and recreational beekeepers that have given us feedback on what is important to them with their hives. So the database is developed through University of New England, and that's our decentralized model where any queen breeder can get involved with the program, Plan B, and they can put in data that is meaningful for them about their own honeybees. And if there's enough data tied to information about those queens, pedigree if you like, so what at least were the source of that queen's, what was her mother, genetic source. If we know that, enough production information, health information, and pedigree information, then we can generate what's known as an estimated breeding value. So that gives a beekeeper an unbiased view of the quality of that queen compared to her relatives within a population of honeybees. But we're getting ahead of ourselves. What is our problem? The problem is we want queens. We want queens. Oh, can't really see it. We need queens. We want queens. They keep our hives productive and keep us getting honey or income from our favorite invertebrate livestock. So what's our problem? Queens, when do we want them? Now, just kidding. We want them within ideally the time that express posts should take to our premise, work or home, or by pickup. So in these trying pandemic times, obviously Australia Post is under the pump. Many packages are taking much longer because of the higher volume. So that's another pinch point for the beekeeping industry that existed before the pressures of the pandemic on all of our infrastructure here. So this is one issue, but basically the program of Plan B was implemented because we identified that there's a real risk to industry, both from access to queens and access to quality queens for beekeepers. Because as we know, the queen is the engine room really of the colony. She's the mother of all the bees in the colony, and she provides all the genetics that colony shows to you in different ways. It could be the temperament of the colony, the ability to produce large or small amounts of honey. Is it susceptible to different health stressors, pathogens such as chalk brood, European foul brood? Is it susceptible to more small hive beetle than others? Some bees bite small hive beetle, others are just like, oh yeah, small hive beetle, come on in to the hive. So we know our problem, we've got a queen issue. Now, who wants them? Well, it turns out a whole lot of beekeepers potentially do. New South Wales is the biggest beekeeping state in Australia, and as of October 8th, we have over 13,000 registered beekeepers. And with those beekeepers come a number of hives. So between recreational concession licensees, and commercial beekeepers, there are over 370,000 beehives registered in New South Wales. And that's a low number because, as we know, healthy hives expand. They swarm, or the beekeeper manages those hives to prevent swarming, but has to relieve the population some way. Typically that happens through splitting a hive. So we know our issue: access to quality queens in good time and in good health. and also availability of queens. So Australia is a very large country, and it has these strategic kind of beekeeping, classical beekeeping areas, which are constrained typically by climate and access to services. So our high population areas typically follow kind of where our beekeeping areas are, where it's kind of, you know, follow the water, follow the flowers for bees and beekeepers. There was a nice paper made on studying the pneumatic movements of commercial beekeepers. And so this diagram from the paper cited there just shows where most commercial beekeepers go through their season. So our larger squares, Robinvale, Warwick, Stanthorpe, those have major pollination events. And also, I think we've got Keith, which is a major pollination event for Lucerne. Robinvale is almonds, go figure, the largest livestock movement, mass migration movement in Australia is to almond pollination. It's not cattle movement, it's not cattle mustering, it's bee mustering. So that's just, I suppose, a point of interest to show that these locations that are traveled very commonly by beekeepers. Typically, they don't have a lot of queen breeders there, and we have very few queen breeders actually in the nation. So they all want queens, but why is that? Well, we asked them, and we assumed certain things, and we wanted to test that. So my colleague, Dr. Chapman from Sydney Uni, and I, we surveyed you guys, and we found we presented through this heat map that Nadine put together, that there are traits that are valuable for beekeepers at different scales. So you can see the blue, the deeper blue squares are those that rated highest for traits or characteristics of a beehive that beekeepers really wanted to see and increase in their operation. And those squares in the reddish or pink were the lesser valued by our survey respondents. So as you're looking through, you can see honey production is the highest ranked trait. Brood pattern is another high ranked trait. So in your brood nest, what's the quantity of viable brood? So that pattern of, sealed brood, you can see it's very solid, or if it's patchy, it could be a disease issue, or it could be a queen issue. Either she's getting older and she has less sperm to fertilize those eggs with, or she could be poorly mated. So she didn't mate with a high enough quantity of drones. Sydney Uni researchers found that some queens could mate with as many as 50 different drones, and that is a vital component of their reproductive strategy to impart, I suppose, that diversity of traits and chromosomes that the drones are bringing into the hive. So the more diverse mates a queen has with different drones, the greater chance that her brood viability will be very high, which translates to increased population, which can translate to increased honey production, though you can select for honey production as well. So we'll get further into that. If you're looking at this heat map and you're thinking, oh, well, I wouldn't have rated that such, guess what? Good news for you. I have the solution. Whip your phone out, get your camera open, and take a picture of this QR code, because we've got another survey open and we would love your feedback. So Plan B is only as good as the feedback we get on any number of things that we're studying with our reference population. So whether you've got, your one hive for honey production and your garden pollination requirements, or you've got 10,000 hives that you take to almonds, you take to honey production, you take to apple pollination, etc. We want to hear from you. So please copy this QR code and you'll be taken straight to our survey. So we're looking to get a lot of beekeeper insights and knowledge about what traits are of value to you. So thanks so much for taking that action for us. And on that queen subject, which is what this is all about, is how do we get them? So not only do we have an access, I suppose, issue with transport, quality is an issue, And a lot of people maybe are getting started in beekeeping and don't know how to get them. And the answer is pretty much old school. Word of mouth is still kind of king in the beekeeping industry. But the not-for-profit Australian Honeybee Industry Council and Australian Queen Bee Breeders Association, they both are looking at, we'll just move that, so that's the Australian Queen Bee Breeders Association logo. They are looking at getting a list of Australian queen breeders in one place for ease of the customer accessing those suppliers. Follow on from that, what is a good queen? Is it a black queen? Is it a yellow queen? Is it a queen whose colony produces this brood nest that has nice ring of food, or this harbor bridge pattern of food over the brood? Or is it a queen that produces wall-to-wall brood? The answer, as happens many times in beekeeping, is it depends. So we can select for all these things. Color is a selectable trait. Brood pattern, brood orientation in the brood nest is a selectable trait. We want to know what you value. So in case you didn't get that QR code last time, this is your last chance. 1, 2, 3, 4, 5. All right, so with Plan B, this is basically our goals. So Nadine's got them starting from the top. Do training, defining your objectives. So what are your top traits? Define how many times a season you're going to evaluate those traits. Define your queen identifiers. All of these elements to our program, Nadine and I have presented in a thorough recorded workshop that's available to you online, and I'll give you those links at the end of this presentation. But they all are explained in our Plan B breeding manual, which you see on the left there. And this is a document that's in real time, it's a living document. So we want beekeepers' feedback on this. So please download it for free from AgriFuture's website. If you just search up Plan B manual, you'll be sure to find this. It's either a free download or you can buy a hard copy from AgriFutures. So do let us know what you think about it. It explains all the traits that we've outlined in the survey, how you would select for them and record in a standardized way so that we know that we're comparing apples to apples. With that first step, it's so critical, education, and that can have many different pathways. So at Tocal College, we're a registered training organization, so we develop these resources, these ag guides on different topics in beekeeping that set you up for success in beekeeping. So with queen bee breeding, we've now, with Plan B, leveraged the investment that we've got from the federal government, state government, horticulture industries, and a few beekeeping, private beekeepers to build a honey shed and a bee training facility. So this season, pending COVID travel restrictions and vaccination status, we will be able to deliver commercially relevant training out of a commercial scale honey processing facility geared towards queen breeding and nutrition work. So we really welcome you on that site once we're able to have visitors. But if you don't have the means or the time to attend training, I would suggest to you that you have the power to train yourself. Many beekeepers live in remote areas of Australia and just can't set the time aside or the expense aside to travel to training. And I know a beekeeper in the middle of nowhere that train themselves in artificial insemination of queen bees by a YouTube video. So anybody can do it. It takes the will and practice. I encourage you guys, grab those resources, whether you have a mentor, you work for a queen breeder or beekeeper, give it a shot. With queen breeding, practice makes perfect, glasses may be necessary. So what you're seeing in this image is a larval transfer or grafting. So you graft that less than 24-hour-old larvae into what's known as a cell cup, and we raise that in a specific colony that we've managed, and we're feeding in a way that stimulates it to raise queen bees for us. So top right, you're seeing those cells. A couple days later, they've been feeding them royal jelly. You can see that nice little pool of royal jelly up the top of the cells now, and we keep them oriented down this point so that the queen that's developing inside that cocoon, that queen cell as we call it, isn't getting damaged So you can learn on your own, but it's extremely valuable as well to get a mentor or work for somebody. What set me up for success really was after I studied insects at uni, I decided, well, I need practical experience. So I worked for queen breeders in California, catching queens, caging queens, fixing up nukes. I worked for honey producers in North Dakota. I came to Australia and I worked for the Horners briefly, extracting honey. I worked part of queen season for Graham Beach in Queensland. And I went over to WA and worked for queen breeder Ron Clark and got an insight into Department of Ag WA with Dr. Rob Manning. So there are many pathways into beekeeping and to enhance your beekeeping knowledge. Slavi Nenov, our bee manager at DPI for Plan B, is another classic example. He threw himself into the industry and he's worked for many different commercial beekeepers in Tasmania, in New Zealand, in Bulgaria, and he's a critical component of this project. So I'd recommend to anybody, get in the ring. If you're thinking maybe I want to have a beekeeping business, the best learning I had was working for different people, and it just opens your eyes to so many different things. So back to Plan B project. This will help you once you've got your queen breeding steps kind of nailed out. You'll be able to take that next step into points of interest around not just queen production, the act of producing a queen from that fertilized female larvae up to hatching from her queen cell and mating in her nucleus colony and checking her quality post-mating. You'll be able to look at things like, what traits do I like about hives? How will I record them? And I'd suggest this manual as a great starting point to you to give you some guidelines on how to record these different traits. So after you've downloaded it and trialed a few different traits, we'd love to hear your feedback on how you went with the manual, because we will be updating it with what we've learned ourselves and from commercial beekeepers who have trialed the manual. So this is one of our data sheets. That's kind of one of our day-to-day data sheets. So vital that you have hive identifiers. So each individual hive, once you've collected a record, you can track it back. So a bit like traceback for disease. We want to know our queen status, population, because population affects how much honey that can be produced out of a hive, queen origin, basically what's her pedigree, and you change your data sheet to suit. So you can work with Nadine or myself, and we'll tailor a data sheet for the traits that you want to record and select for in your operation. With breeding, back to that, that mating quality, I just stress anyone wanting to get into the nitty-gritty of queen breeding, it's not rocket science, it's just hard work over a lot of time. So work on getting out any kinks from your queen production side, that setting up cell starters, finishers, mating nucleus colonies and mating yards, get that kind of ironed out, and then think, okay, what can I do next? What information can I collect that will help me in my goals for my beekeeping? And the world's your oyster at that point. Once you kind of gain this knowledge and you're really moving, there's so much to learn in beekeeping, as we know, that you could spend, 3 lifetimes doing it. So if you want to know more about queens and drones, I'll have my email at the end of this presentation, and I've got this nifty little paper just reviewing all that we know about queen and drone fertility traits, because with other livestock, they've advanced, selection on production traits, like in dairy cattle, for example, milk production, or health traits such as heat stress traits, disease resistance traits, and then also reproduction traits. So we're looking to learn from what these other livestock industries have really ran with to improve their overall industry productivity and really business viability, run with that, and see what we can translate over to beekeeping. So if you're interested in that paper, it covers a number of different topics relevant to queen production and quality. The age of the larvae is so important for our queen productivity potential. Ovarial quantity is linked to the age of that larvae that you graft. So the longer she's fed royal jelly, the more egg-producing units she develops, potentially larger spermatheca as well. That's that sperm storage organ on the left. And her capacity to mate is greater the larger the queen she is, the more stronger flyer, larger spermatheca, she can store more sperm, she can have the opportunity to lay more viable offspring. Drones as well. We'll see if I can play this, this video for you. Drone o'clock at Tocal College. Drones are a vital component of Plan B. Obviously, if a queen's mating with up to 50 drones, we're going to need thousands and thousands and thousands of drones. So not only is queen rearing important, but drone rearing is just so vital to success as a queen breeder. So to wrap this up, basically our issue is with queens. We need to know for ourselves what's a quality queen, what's our queen rotation, if we need that, if we want access to queens, who's available to sell them. And we really don't have a lot of queen producers or breeders in Australia. So I'd encourage anyone who's interested in this, you know, search for those resources, mentors, work for a queen breeder, look at our Plan B manual or queen breeding ag guide, you know, seek out those people that are doing these things because they're looking for workers. The Australian beekeeping industry is really pressed, like other livestock industries, for access to employees. So I would say to anybody looking into beekeeping as a sideline business, you know, get your hat in the ring, work for a commercial beekeeper, you'll just learn so much. And if you want to follow us in real time, Nadine Chapman from Sydney Uni and I and Tocal College put a lot of updates about Plan B through the Extension Oz Professional Beekeeper Network, which is a website for peer-reviewed topical information for queen bee production in part, and any other topic that is of interest to professional beekeepers. So hot topical information, it's peer-reviewed, so it's not just, you know, ask an instant expert online. We've brought the experts together from research, the beekeeping industry, government agencies. They produce these articles, they peer review them together before they go out online. So please follow us on your social media of choice. And if you're in this space where you're an industry leader, expert, government agent, researcher, we do have a few spaces left in our Writing for the Reader development workshop, which is funded by AgriFutures on the 26th of October. So scan this code and I'll get your registration of interest for that half-day workshop. Other than that, thank you guys so much for your time, and would really love if you downloaded our manual and had a peek and let us know what you think. So this is just the other day, we sold our first artificially inseminated queen that I produced last season for Plan B, and Slavi and I and our contract beekeepers, we drove them, the research population down to almond pollination this year. So on average, research population produced 9 kilos over, I think it was 9 days of wax honey, canola honey, neighboring canola field, and bees in that 9-day period. So we're collecting heaps of data from the DPI research population of hives from honey production, temperament, disease resistance, and some traits around pollination, pollination-related measurements, because we've got horticulture industry investors that really want to know more about the pollination aspect of honeybees. So thank you guys so much. For our resources that dig deeper into our selection manual, we've got videos as well. So just look up AgriFutures Plan B online and you'll be led to our website. So you can look up our video on trait recording, our downloadable trait recording files, Queen ID files, and all of our direct updates are on that AgriFutures website. Otherwise, they come through Professional Beekeepers as well. So thanks so much, and thanks for your attention, everyone.
Our next presentation comes from Annalise Austin, Research Fellow for the Bees for Sustainable Livelihoods at Southern Cross University. Annalise is talking about gender equity in beekeeping for PNG and value-added bee products.
Thank you to everyone for tuning in today for the Tocal College Field Day event. My name is Annalise Austin and I'm an early career researcher and PhD candidate from Bees for Sustainable Livelihoods at Southern Cross University. My presentation today has two parts. I'm going to start off by talking a little bit about the work that we've been doing in relation to improving gender equity and social inclusion in beekeeping in Papua New Guinea and Fiji. And the second half of my presentation today will be about something that I am very passionate about, which is the production of value-added bee products. So it's really exciting to be speaking with you all today about this area of income diversification from beekeeping, especially because of the release of Tocal's Ag Skills Guide on value-added products. So to have a publication which has been made here in New South Wales and both based on local resources and methods is really beneficial when you're starting out thinking about the different products you can make from your hive and how you can transform them as well. So the research I'm currently conducting is part of an ongoing Australian Centre for International Agricultural Research, ACR, project to support productive, sustainable and inclusive honeybee sectors in Papua New Guinea and Fiji. This photo below was taken in Goroka in the Eastern Highlands province. It's one of my favourite pictures actually, after a Women in Beekeeping workshop which was held to discuss women's roles in beekeeping and identify some of the challenges which women face participating and benefiting from beekeeping enterprise and also participating in beekeeping training. So in Papua New Guinea, highly defined gender roles and constructs often influence how women can participate in certain activities and the benefits that they gain from their participation. So it is largely a patriarchal society and women are mostly excluded from household decision making, particularly about finances, and often fair and equal representation in formal employment and also politics. So inequality in relation to gender really runs right through both the formal and informal parts of women's lives. So there are really several key reasons why beekeeping is an activity which may provide opportunities for women in Papua New Guinea and Fiji. Firstly, there are already women who are beekeeping in both these countries and a few of them are quite successful. And that's sort of despite having access to sort of less resources and training opportunities compared to men, and also just generally the inequalities which they face in their lives. So it's quite an important point because beekeeping, is not a new activity for women. So there doesn't appear to be any really strong gender roles aligned with beekeeping. But what has happened over time is that when beekeeping has been introduced into Papua New Guinea, for example, previous development initiatives just excluded women. They weren't inclusive to women. So men were the ones who really got all the information and extension, and they've largely, really held that close. So this has impacted women's uptake of beekeeping just generally, and also their visibility within the beekeeping sector. So the image below really just outlines just a few of the benefits, but for me, I really think one of the most important benefits, particularly for women in Papua New Guinea and Fiji, is the time allocated to beekeeping compared to the potential profit. So, if you look at something like growing coffee, which is a really popular agricultural cash crop in Papua New Guinea, for the time it takes you to harvest or to plant, to prune, to manage, and then to harvest your coffee, the number of hours you put in, if you compare that to beekeeping, you require far less hours and you make a whole bunch more money. So I just think there are some, time use versus kind of economic factors which add up in relation to promoting beekeeping as an activity for women. You can keep bees quite close to your home, and I think this is a really important factor for women because travel, particularly in Papua New Guinea and Fiji, can be unsafe for women, or alternatively, they need to seek permission to travel away from their home as well. So if you can keep your bees on your land, which is within your community, there's, really limits sort of the safety and logistical issues around having to access a site which might be away from you, and also in relation to security for your hives, you can have them right there as well. So honey is an incredible substance. You know, honey and wax both have so many amazing uses, and I'll speak about those a bit later on in the presentation. But you know, the really key thing for me about honey and beeswax, but particularly honey, is it stores really well. And if it's stored correctly, honey will keep for a very, very long time. They've found honey from, you know, out of the tombs in ancient Egypt, which when you think about that is absolutely incredible. I'm not sure if you would eat it, but still, it just shows that, you know, being a hydrophobic substance, it doesn't deteriorate or rot in the same way that other fresh produce often does. It doesn't require refrigeration, doesn't require cold storage. So, you know, you could store honey away and then go and cash it in or sell it to a processor when you need to meet, you know, school fees, or if anyone in your family needs medical treatment. So I kind of think of it as a bit of a bank or an investment for, you know, rural farmers who live in quite remote locations at times as well. So how have women been participating in beekeeping, and what are some of the challenges that women face specifically benefiting from their beekeeping enterprise in Papua New Guinea and Fiji? So this really does look a little bit different when you compare both countries. In both countries, women's engagement in beekeeping and just across the beekeeping value chain is generally very low. However, many women assist their spouse in a family beekeeping business, but there are only certain sort of activities that we see women really participate in. So generally speaking, that has to do with the processing and packaging of honey. And that's in comparison to kind of actually managing beehives. So what we find is that women don't have a lot of the practical beekeeping skills required to successfully look after their own bees. So there are a lot of other challenges that women face. You know, one example is if a woman wanted to start beekeeping in Papua New Guinea, she would have to ask her husband for permission. She would have to ask him for permission also to access the money, even if she had earned a portion of that income. She'd have to ask her husband for permission to travel to training as well. And so that really presents a problem for a lot of women in Papua New Guinea. One, there's just the logistics of traveling everywhere, which can be quite difficult and also can be unsafe. But women do a lot of different jobs in their household. You know, women in Papua New Guinea and Fiji are considered to be time poor. You know, they spend a lot of their time looking after children and family and tending to their household, getting water, firewood. They're just, you know, really busy, to be quite honest. And so they often, you know, don't have that time to travel into town. And if they leave their houses, that presents problems as well. Also, any unaccompanied travel, and particularly if that happened without permission, can really incite a lot of jealousy and distrust in the household as well. One of the, you know, overarching factors which was limiting women's engagement in beekeeping, I sort of discovered during a study conducted in PNG in 2019, and that really was that women just weren't aware of beekeeping and the potential benefits that beekeeping might provide them. So there are a few cultural factors which influenced that. There was a perception that beekeeping was a male activity, and that's despite there really not being any strict cultural taboos which prevent women's engagement. So you know, there's been a real focus on our project about trying to improve the visibility of women who are working within the beekeeping sector and to encourage and promote women's engagement in all of our activities, you know, not just my specific areas, but also having women engaged in the queen bee breeding programs and different aspects of the associations as well. So, you know, a large part of what we do is that we spend time building capacity with a lot of the men so that, you know, to really understand why being more inclusive and engaging those women who are participating and trying to encourage others to participate as well, you know, is beneficial to them and their organizations. I just wanted to share this photo with you. This lady, her name is Henna, and when I first returned from Papua New Guinea, she messaged me. She was so incredibly excited, and she told me this story. Her and her friend were out beekeeping. They were dressed up in all their veil and their garb and the whole lot of gear, as you all know. And they were working away, and two men walked past and addressed them as though they were men, because they couldn't tell from the distance and from behind that they were women. And they were just so empowered by that. So they turned around, and the men realized that they were in fact women, and the men were really shocked and amazed that women were beekeepers and that they were out there, and they weren't afraid of the bees. And Henry was just so happy, that for that moment, I suppose, in her life, in her existence, in her community, in her culture, in their society, for a moment, it just wasn't based upon their gender. And for that moment, they felt equal. And, that is really a marker of empowerment, even though it's temporary. It's that feeling that, you don't have those barriers on you. So for me, it really shows, or it just demonstrated or reinforced, I suppose, how powerful this activity potentially is for women in Papua New Guinea and Fiji, and really ultimately for all of us, even here in Australia, we're the same once we're in that bee suit. You can't, really tell gender or race or religion, and I just think that's a really beautiful thing. So how do we increase women's engagement in the honeybee sectors in Fiji and Papua New Guinea? This is really the question that my PhD seeks to address. There are a lot of different methods and frameworks which you can draw upon and have been used previously throughout the Pacific, but there isn't a lot that's specifically related to beekeeping and takes into account some of the really unique circumstances which occur in women's lives. So the diagram that you see in front of you is known as the gender transformative framework, and basically it addresses gender inequality by looking at the three domains of women's lives, and that's agency, structures, and relations. And so our program is really designed to address either one or more of these different domains with any set activity. So the centre point of my PhD research is on community-based mentorship and how that may support women and men beekeepers, also family groups, to engage with beekeeping, but also increase their beekeeping skills and knowledge, and also have support within their community as well. So there are a lot of beekeepers in Papua New Guinea who have hives, but do not produce nearly enough honey to make a living. So this program is really aimed at existing beekeepers and improving their skills and really relations within the sector as well. The other area of my PhD research is looking at trialling different technologies to reduce the burden of beekeeping for women. Although this hasn't been an issue that we've had come through from PNG and Fiji, in a lot of the research about women in beekeeping for development initiatives, it mentions that beehives are too heavy for women to handle, and that's why they don't keep bees. So I'm investigating in Papua New Guinea and Fiji the introduction of half-size frames and boxes, or ideal-sized frames and boxes, to sort of be able to challenge that argument with a solution. And the final area, which links into the second part of my presentation today, really has to do with income diversification from beekeeping activities or the production of value-added products. So if you're going to do an activity in agriculture, it's best that you're really trying to make as much money as you can from the products that you're producing. And one way to do that is to add value by transforming raw products like honey and beeswax into something else that you can sell for more money. As I said, this is absolutely one of my kind of really areas that I'm really personally passionate about with beekeeping, and that's the production of value-added products. So you can see from these photos, these are some of the products that the women in Papua New Guinea and Fiji have been making. Some really simple candles, got some coloured candles on the left there. The women in the group below participated in a workshop for value-added products, two workshops which took place in Fiji earlier in the year. and they make candles and cosmetics, also some honey goods as well. So, you know, what I'm talking about today not only ties in with my research, but it's just something that I enjoy to do and something that I earn a little bit of income from as well. The other aspect of value-added products, which although I'm not talking about today, I did want to mention is, you know, basically it's about diversifying your income from beekeeping. So when I talk about value-added products, I also like to mention things like agritourism, you know, providing training, mentoring, producing inputs. There are a lot of different ways you can add value to a beekeeping enterprise, particularly here in Australia. And I think things like agritourism are just going to take off and continue to be a really popular way for people to go on holidays and experience rural Australia as well. So we are here to talk about value-added products. So what exactly does that mean? As the name suggests, sort of value-added products or VAPs refer to taking raw product and transforming it into another saleable product. So this doesn't just apply to bee products. There are many examples of VAPs in agriculture today. You know, a farmer taking seconds produce and making a syrup or dried fruit, you know, reduces his wastage and also maximizes potential profits that would have otherwise be wasted. So that's value adding as well. The value of doing this, is not just in terms of making money, but really in relation to beekeeping and the products we can make, like just making these products yourself for your own use or for your friends and family. It's a really fulfilling way to make the most of all of the products from the hive. So I think an important place to start off when we talk about value-added products, and considering many of you watching today might be newer to beekeeping, is probably a bit of an explanation of some of the substances which bees produce and which are typically used in value-added products. So picture one there is obviously honey, and that's really for most of us the first sort of bee product that we will have access to. So honey is remarkable. It contains heaps of vitamins and minerals, also like a wide variety of amino acids, enzymes, phenols. So it is really an incredibly, you know, unique natural substance. So to make honey, bees store nectar in their honey stomach. And in there it kind of mixes with enzymes which convert the sugars from really complex sugars to a more simple sugar for the bees. So once back in the hive, that nectar will be stored in the cell of honeycomb, and a combination of factors, including sort of the temperature of the hives and the bees fanning the nectar with their wings, reduces the moisture content, and ultimately we get what we know as honey. So there are so many benefits of consuming honey, and increasingly Australian consumers are really looking to substitute some of those refined sugars and artificial sweeteners, and honey is a great natural alternative to sugar and can replace sugar in so many different applications. So the second photo we have there is beeswax. I love honey, but I really do think beeswax is pretty amazing. So there are so many ways to use beeswax. It's an incredibly valuable product. Beeswax contains more than 250 compounds, and it's used by the bees as the foundation for their nursery, food storage, and also just their home. So it's secreted from 8 wax glands, which are located on a worker bee's abdomen. And then the bees, you know, as they do, work together to arrange that wax into the hexagonal pattern that we all know and love in the hive. So clean, rendered, unadulterated Australian beeswax is a product which is really in demand. You know, we need beeswax supplied to our input suppliers so we can have a steady supply of Australian foundation sheets, which is really important. So it's an incredibly important substance to beekeepers. Number 3, in the corner there is pollen. So bees collect pollen when they're out foraging, and you can often see their little pollen pants as they return to the hive. So you can actually harvest this pollen by placing a screen at the bottom of the hive, and it kind of forces the bees to crawl through and drop their little pollen bags. So you just have to be aware that if you're going to do harvest pollen, or really anything from the hive, you just need to be careful. Pollen's a food source for the bees, so you have to remove those traps intermittently so that bees are able to stay well nourished and really healthy. But again, this is another product that is becoming more popular in health supplements, and I've also just seen it on the menu in restaurants and cafes and on the top of acai bowls and different things. So number 4 in the bottom corner is propolis and propolis tincture. So propolis is the dark brown resinous substance which bees use to fill gaps in the hive. It's made from a mixture of saps and resins which the bees collect, and it's mixed with saliva and beeswax. So it really does have a lot of medicinal value. It's known to be antiseptic, anti-inflammatory, and contains one of the highest natural amounts of antioxidants. So you often collect a little bit of propolis when you inspect your hives, just in the process of scraping the sides of the boxes and cleaning up the frames, where your bees have gone a little bit freestyle with their house renovations. But you can also use harvest propolis using a mat. So again, you just want to consider how much energy it takes the bees to make this substance, and you don't want to deprive them of anything that they might need to stay healthy and strong. Picture 5 is actually royal jelly. So royal jelly is secreted by nurse bees and is fed to all the larvae for the first 3 days. And then any larvae that are destined to be queens, royal jelly is fed to them right up until the point that they pupate. So it has played an incredibly important role in Chinese medicine for a very, very long time, and it's now really widely available in cosmetics and particularly skin creams. So there hasn't been as much exploration about health benefits of royal jelly, but it definitely does have antibacterial properties. So the final substance, I suppose, I'd like to mention today is bee venom. So I included this in here because apitherapy is just gaining, more interest, and bee venom has been used as a treatment for the conditions such as arthritis since like ancient times. So again, very long use of this substance. Bee venom can be extracted from bees, but sometimes this therapy really just involves people being stung by a bee in controlled circumstances. So some of the proteins in bee venom are said to stimulate cortisol production, which is anti-inflammatory. So that's why it has an impact on conditions such as arthritis. So, if you've been getting stung by your bees working in your apiary, they're just trying to help you out with a bit of a free apitherapy session on their behalf. So I really wanted to spend just a few minutes talking a bit more specifically about some of the products you can make from the substances that are coming from the hive. So one of I think the most versatile hive products is definitely beeswax, and one of the most popular value-added products is absolutely beeswax candles. So candles beeswax candles act to clean the air, and I think they have just a far superior burn than you find with paraffin candles and also soy candles as well. Beeswax is natural. I don't add anything else into my candles. They have a really lovely, natural, sweet honey aroma that I just really enjoy. And there's so many different ways you can produce candles. The ones in the top corner there are dipped candles. The ones on the other side are made from, using really intricate molds, and they're beautiful as well. So really an incredible array to make candles from beeswax. In the middle, on the top row there, you see a picture of honey. So I included that here because, you can take raw honey and infuse it with botanicals or herbs or spices. You can have creamed honey, and you can see there's some blueberry creamed honey. So again, you can add a whole bunch of different stuff to that. And you can cook with honey, you can bake with honey, you can put honey in lotions and skin creams. So there are a lot of different opportunities to add value to honey. And even for me, when I see like honey that's differentiated between floral sources, so in my opinion, that's adding value to your product and informing the consumers more about it as well. So I think that's really positive. So in addition, beeswax can be used to make lotion, salves, moisturizers, lip balms, an incredible array of kind of body products. And again, a market that people are really interested in, sort of reducing the unnatural kind of cosmetic products that we put on our skin every day. So I found that lip balm's incredibly popular, as is sort of moisturizing lotion, and both of those I use myself as well. So next to that you have beeswax wraps. These are really popular at the moment. They're still one of the most popular products that I sell, and people are really looking to reduce the amount of plastic that they use. And so these wraps, you know, they're reusable. I've used a set for like 2 years, and so they really provide that alternative, which I think has been largely missing from the market outside of kind of Tupperware. So very popular. But beeswax can also be used in so many ways, and it has been used in a lot of different ways throughout history. So a wood conditioner, beeswax can be used as a waterproofing agent for canvas. You can waterproof tents and seams and shoes. And also down in the corner there, I just put that in there. Beeswax has been used for a really long time for many different applications, but one of those applications is actually batik dyeing. So if you've ever been to Indonesia, seen those beautiful fabrics, beeswax is actually used to create those really intricate designs. So I just put this slide in to show some of the ways that I use honey. So I bake with honey a lot, and you can see some cute little honey cupcakes there with a honey syrup and also fresh honeycomb. There's some honey throat lozenges. Again, really diverse. You can add ginger, you can add lemongrass, honeycomb at the bottom. Who would have thought honeycomb often doesn't actually have honey in it? So that's something that is really popular around our house. I also make a really simple syrup with honey and lemons, and I use that in hot and cold drinks, in my baking, and also in some savoury dishes as well. So there are a lot of different ways you can use honey and add value to honey as well. So I also just wanted to touch briefly, all these candles in these pictures are so beautiful and intricate, but beeswax candles can be made in a lot of different ways. And when I'm overseas in Papua New Guinea making candles, or making materials up for people to use overseas, I use anything. I've made candles from milk cartons, from toilet rolls, really just anything that's going to be able to tolerate the heat and hold a nice shape. So don't get overwhelmed if you don't have access to really super fancy silicone candle molds or anything. Just try and look around the home and use what's available to you as well, because it can be a really accessible activity to enjoy with the family. So again, thank you so much for tuning in to my presentation today. I hope that you learned something new, or learned a little bit more about some of the products you can make from your hive. If you'd like some more information, check out the new Tocal Ag Skills Guide on value-added products. If you'd like some info on our project, please follow Bees for Sustainable Livelihoods on Facebook or Instagram, or feel free to get in touch with me. And you can read my research on the barriers to women's engagement in beekeeping in Papua New Guinea at the link below. So thank you very much.
Our next speaker is Dan Cook from QUT in Queensland, talking about the thermal impacts of beekeeping on bees in beehives.
Hello, my name is Dan Cook, and today I'll be presenting my research on the thermal impacts of apiculture on the bee colony. So I'm a PhD candidate at Queensland University of Technology, due to finish in the next couple of weeks, and I'm conducting transdisciplinary research between apiology and industrial design, which is the design of products and how people use things. And what I'm looking to do is address the gap between apiology and apiculture. As well as this, I'm not just a theoretical beekeeper, I also manage the QT research apiary, which is currently around 50 hives, but we're expanding up to 100 in the next couple of months. I'll get rid of my ugly mug and then we can get on with it. Now, this research is partly funded by Hort Innovation and the Australian Government, as well as QUT and Plant Food Research. This presentation is a summary of recent research, and we've released this in a Journal of Economic Entomology in a paper entitled Thermal Impacts of Apicultural Practice and Products on the Honeybee Colony. And if you fancy some light bedtime reading or having trouble getting to sleep, then the link is down the bottom for you. Now, as an industrial designer, I wanted to look at the entire practice of beekeeping from basically the kind of bee and cell level all the way up to the truck level. And to this end, I asked two main questions, which was how does migratory apiculture impact bee colonies, and what are the processes and pain points in migratory apiculture? Now, we found several. My entire study looked at these kind of 5 main areas, all affecting colony health, which were hive design, the practice of beekeeping, transport, pollination services and audits. But today we'll be looking at 2 of these things, which are hive design and practice and their impacts on temperature. So why does colony temperature matter? Well, chilling the brood causes bee retardation and it damages cognitive functions, mainly affecting their memory. And what this means is that the bees can't find their way back home, or they can't learn their location from the hive, so basically they don't come home. Now, colonies require heating, and if the bees are doing heating, then they are out getting less nectar and doing less pollination. And you're also introducing a measure of stress. Now, I'd like to define the word stress here. Stress occurs when animals have to make prolonged physiological and behavioural adjustments in order to cope with their environment. Now, this is an important definition because we'll see that creating increased heating activity in a bee colony is a form of stress. So how do the bees heat the hive? Well, a bee can generate temperatures up to around 43 degrees Celsius, and they do this by flexing their antagonistic wing muscle pairs. And now this came about evolutionarily through pre-flight preparation. By being able to warm themselves up on cold days, they gain a competitive advantage to get to that nectar or pollen before other insects who can't heat themselves up do. Now, one of the fascinating things here is that heater bees can be aged from 3 to 27 days old after they emerge from the capped cell. This is interesting because a lot of this period actually overlaps with many other jobs, and importantly it overlaps with foraging for water, propolis, nectar and pollen, and they can jump back into this role when they're needed. Now, there are 2 main methods of heating up brood. The first one is a thorax pressing, where the bees do a little push-up on top of the cells, heat themselves up, and they transfer the heat straight through to the cell underneath and the cells around. However, this is not as efficient as the in-cell heating methods that they use. And this is where they will crawl into a cell within the brood comb, and in this brood comb there's normally about 5 to 10% of the cells left empty in healthy comb, obviously more if you've got problems or a poor queen or disease. And they'll crawl in and they'll basically heat themselves up, transferring their heat energy to all the cells around them, but also the cells on the opposite side of the foundation. Now, you can see this by looking for their abdomens pumping in and out when they're within the brood nest cells. Now, this was previously thought to be a resting behaviour or a cleaning behaviour, but has since been shown through thermal camera images like the one on the right just to be actually heating. And they can do this activity for up to 30 minutes, pretty much continuously. Now, heat generation takes a lot of energy. In fact, to give you some numbers, it takes about 65 millijoules per second, which is about 3.9 joules a minute. And that produces a thorax that is about 40 degrees Celsius. Now, to put this in context, a milligram of honey contains 12 joules, which is enough to lift half a kilo or 1 pound up to about 7 feet or just over about 2 meters. And 1 gram of honey is equal to about 12 kilojoules, which is equivalent to about 3 food calories or kilocalories. And the adult human needs about 8,700 kilojoules per day or 2,200 calories. Now, when we talk about energy in time, we talk about watts, and 1 joule per second is a watt. So to put this again in context, we can talk about how the beehive and maintain the brood nest temperature uses about the same amount of energy as running a 20-watt light bulb continuously. And this is in normal conditions, not in a harsh winter cluster or in a summer condition. So I wanted to ask a couple of questions, having defined the parameters of temperature. The first was, what happens to a beehive when we put a cool or a cold super on top? Well, a number of things. First, the heat rises up from the brood nest, and this heat will start heating up the cooler frames and comb or foundation. And the colony beneath now has a heat deficit. And they can't basically move up to take advantage of this because above them is cold, there's no stores, there's no brood, and normally there's a queen excluder preventing the whole colony moving up. Basically, this deficit means that they need to start doing some increased heating activity to help maintain that brood nest at around 35 degrees Celsius. Now, I wanted to know how much energy that took. So I did some theoretical calculations and we created a mathematical model. And basically what we showed was that heating up foundation, either plastic or wax, there's not much difference between the two, takes around 150 kilojoules to take a super stored at 15 degrees Celsius up to this optimal temperature of 35 degrees. Now, a sticky or extracted comb will take double this at 350 kilojoules. And if you're unlucky enough to try and actually throw on a full super of honey, which hopefully no one's actually doing, or you're just wondering how much energy is contained within a full depth 10 frame super of honey, it's about 1.3 megajoules of energy, which is a vast amount. Now, one of the questions you might have in your minds at this moment is, if it takes more than twice the amount of energy to heat up stickies as it does to heat up foundation, should I always be putting foundation in? And the answer to this is a resounding no. That's because the energy required to build out the wax foundation to proper comb structure is around 382 megajoules of energy. It's absolutely huge. And basically that's 283 times more energy than it would need to heat up those stickies. Now again, I like to put these things in a context. So that 382 megajoules of energy to build that comb is the equivalent to 65 Domino's Meat Lovers pizzas. So that's a lot of pizza, and that's a lot of energy. But I was still looking for a better way to express these numbers. So I came up with a new unit, which we're going to call bee minutes. And a bee minute is basically the number of minutes it takes a bee to do heating work. So we can see here that foundation, whether it's wax or plastic, takes around 35,000 minutes of bee activity to take it from 15 degrees Celsius to 35. An extracted comb or stickies take around 80,000 bee minutes. So 80 bees for 1,000 minutes or 1,000 bees 80 minutes. And it's a lot of work. Now if we want to put that into a real world application, now our real world application is this graph here. This is Brisbane mean monthly highs and lows. So the warm coloured bars are the monthly high temperatures and the blue coloured bars are the monthly low temperatures. And this is all daytime. If we then plot the energy required to heat up a super from 15 degrees on each of these days, as shown as the blue line for the cold days and the red line for the warm days, you can see there is quite a difference in the amount of energy required to heat up that super. In fact, it's 3 times more energy. Right? So that could be a lot of foragers out collecting you some nectar, making you some more honey, or going out to do a pollination job. Now, not everywhere in the world looks like Brisbane. So to give you an example of another place I recently did, if we compare this to the San Francisco Bay Area, we get this. This curve basically shows that the difference between a cold day and a warm day in San Francisco, out at Alameda, is around 30,000 extra bee minutes. And this is basically pretty typical of most temperate regions, so this is why this is a good example. Now, having quantified the heat energy that's in a super and how much energy it takes to warm those supers up, I wanted to know how much heat energy is actually stored within the honey that we take away. And I asked two questions, which was, does honey help stabilise hive temperature, and does robbing this honey actually impact the bee colony? So I set up a series of experiments using supers full of either full honeycomb or stickies, and we put them in a special temperature controlled oven. This oven was set to spend 12 hours at 35 degrees Celsius and then 12 hours at 15 degrees Celsius. What you can see is that this blue line is the ambient temperature of the oven. And you can see it basically sits quite nicely at those two temperatures and then drops or rises very sharply. Now this yellow line is the stickies or the extracted comb. And you can see what's happening here is that they are following the ambient temperature very closely. They take a little bit of time to cool all the way down or warm all the way back up again, but it's pretty similar. So we're looking at only an hour or so to actually get that temperature drop. However, when we look at the filled comb, we see that there's not much temperature variation at all. In fact, it's only around 6 degrees Celsius. And what's happening here is the honey is absorbing excess heat energy and then releasing it out when it gets cold again. So to answer the question, does honey help stabilise hive temperature? The answer is a resounding yes. And we can see that quite clearly because the honey acts as a thermal mass. In fact, the temperature rate of change is just 4% of the ambient temperature change. So we can say that the honey provides a measure of thermal hysteresis, which is a resistance to change. It absorbs the excess heat and it releases that heat back out into the hive when there's a temperature drop. So, does robbing honey impact the hive? The answer is yes, very likely. More temperature variation means that there needs to be more heating activity in the cold, more fanning activity in the hot weather, and it means your workers are managing temperature and they're not foraging. So next up, I wanted to know what the impact of the actual hive itself was. Now, this is the Reverend Lorenzo Lorraine Langstroth, the inventor of the hive, arguably the inventor because there are other people who did a lot of work towards it, such as Huber, Zerzon and Propokovich. And basically all of their work accumulated in this gentleman here, Langstroth, bringing to market a commercially viable movable frame top opening hive. You can actually see the work of the others still in Europe in the AZ hives, which arguably are actually a better system for the bees, although not as commercially viable. Now, I'd like to put the hive into context. This was in 1870, and you can see that the boxes in the background and in the foreground and the frame and the wax foundation are all very, very familiar because they haven't really changed. In fact, Langstroth is holding there a Hoffman frame with the self-spacing frames, and that's a printed sheet of wax foundation. So this was kind of the height of technology at the 1870s. So, to sum up, 1870s, state of the art is a wooden box with wooden frames with a bit of wax in it. Now let's compare this to the dairy industry. In 1870, the dairy industry's state of the art technology was a metal bucket and a stool. If you were lucky, you had a young lad, like the guy in the centre of the picture here, who would run buckets backwards and forwards to the shed where they poured it into the churns. If we jump forward to recent years, what we see is that the dairy industry has progressed a long way. Cows are now RFID tagged and identified as they come into feed. While they feed, they are milked. How much milk they produce is automatically recorded. Robotic milking machines analyse the milk as it's going through. There's some separation and homogenization, and it's basically tracked all the way to supermarket shelves. We know exactly how much the cows eat. Now, comparing this back to beekeeping, and apart from the fact we've got trucks and something to move boxes with, we're still a wooden box containing wooden frames, right, with a bit of wax in them. Now, this is where I tend to get a lot of kickback from beekeepers, because lots of people say, well, if it ain't broke, don't fix it. And my favourite answer to this is, I quote Henry Ford, who invented the motor car. And he said, if I had asked people what they wanted, they would have said faster horses. And in our case, we have a product that has been doing really well for an awful long time. And we haven't changed it because we've always been producing honey and it's a great system for that. But it was invented 160 years ago for honey production. And today we do a bit of honey production, but pollination services globally is worth over 100 times more. In fact, it's worth about $240 billion per annum compared to about a $2.34 billion global honey industry. And Australia has a pollination industry that's worth about 14 billion with a B billion dollars. So this comes to that big question of why are we still using a 160-year-old honey collection system for pollination? So to find out the impact this was having on our bees, I asked another set of questions and did some more experiments. I wanted to know what the thermal properties of the Langstroth hive were. I wanted to know how does the hive contribute to heat loss. So I created mathematical models of a hive made from various materials using identical dimensions, just as a kind of a theoretical experiment to show what we could do by changing up our materials and using something with modern material research and design. I set the inside of these hives at the ideal 35 degrees Celsius, and I compared it to external temperatures that varied. Now I know there are going to be some people here who say, well, not every hive is 35 degrees Celsius all the way through. And to them I reply, yes, I know, but doing it any other way, the maths becomes really hard, and I'm not that good at maths. So here are the results. What we found is that a wooden hive uses a vast amount of energy, and you can see that here in this green line. So if you look at the solid lines, these are the hives as a whole. And we see up here at the top, wood uses about 100 watts of energy. And it loses 100 watts of energy at 15 degrees Celsius out of its sides and lid. Whereas something like expanded polystyrene loses a quarter of that at about 23 watts. Now, really interestingly, if we look at the two dashed green lines for wood, we see that both the lid and the walls lose about the same amount of energy. So they're both sat around that 40 to 45 watts of heat loss mark. So beekeepers often ask me what I would do to solve these problems that I'm pointing out. And I say, if I could improve one thing on the Langstroth right now, it'd be lid insulation. It's an easy fix. You can pop down to your local hardware store and there's a myriad of options such as foam or earth wall insulation or any form of the packing foams that we get, which are waste products at the moment. And it's very easy to modify the thick migratory lids into slightly thinner lids but with a big layer of insulation, or place foam on top. Because better lids means you get less energy loss. In fact, you'll halve the energy loss almost, right? And if you've halved the energy loss, that means you've got less colony stress. Less colony stress means that you've got healthier, happier bees. Now these healthier, happier bees are going to be going out and doing more work. They'll forage more nectar, they'll forage more pollen, right? Which is good for you because you get a better return. So how does this all apply to you? Well, to answer this, I'd like to ask some questions. Now there's normally some fairly energetic and active debate at this point, but this is my kind of takeaway. Why do you do what you do? Is it because it's what you've always done? Is it because it's how you were taught to do it? Right? And does this new information shed any light on the practices you do? right? And what small changes can you make to reduce bee thermal stress to make happier, healthier bees? For example, are you still going to super on a cool day? Or are you going to put your supers underneath a black tarp and let the sun warm them up a bit, saving your bees tens of thousands of minutes and getting you more nectar in the hive so that you can have a better honey return at the end? Right. So, I'd like to thank you all very much for your time. Please feel free to contact me through the Tocal, and I hope you all have a lovely day. Thank you very much.
Our next presenter is Ashley Zamek from Hort Innovation, and she's going to talk to us about the impact of netting and how that affects pollinators on agricultural crops.
Hi, my name is Ashley Zamek from Hort Innovation. I'm the R&D manager for our pollination portfolio. We invest in a range of projects, but today I thought I'd go through a deep dive on a project I think would really interest you. So first off, who is Hort Innovation? Well, Hort Innovation is the research and development corporation for 37 different horticultural industries in Australia. You might have heard of other RDCs such as MLA and FISH, but we specifically deal with horticulture, and we do have quite a range of stakeholders. Our biggest stakeholders are probably industries like almonds and avocados, but we also represent quite small industries like nashi pear and custard apples. All these industries pay a levy at farm gate, and this levy is invested in R&D on behalf of them. This R&D tends to be very industry specific and deal with the issues that are facing them now, such as pests and diseases, breeding and biosecurity. Therefore, these larger multi-industry issues that face horticulture, we tend to deal in more of our Hort Frontiers funding model. Hort Frontiers is a co-investment model and aims to really target those issues that are across industry, and this is where pollination fits. Our pollination fund has 3 key themes that we invest in. The first is about management of European honeybee. Secondly, we look to optimize crop pollination. And lastly, we looked at alternatives to honeybees, such as other biologicals or mechanical means of pollination. Today, I'd like to talk to you about our project, Novel Technologies and Practices for the Optimization of Pollination within Protected Cropping Environments. This was actually the outcome of a rural R&D for profit grant that Hort Innovation, along with 5 key partners, was successful in. This $4.3 million program really aims to understand the issues in protected cropping environments and the things that are happening in regards to pollination. This project started in 2019 and is set to finish in 2023, pending anything else happening in the current landscape. The horticulture industry is currently at a point of change. Climate variability will continue to impact crops each year, limiting the assurance of supply to markets. Customer expectations of year-round availability of fresh produce has increased, and retailers are focusing more and more on producers who can meet these specifications. Historically, there's been a lot of investment in the infrastructure of protected cropping for industries such as berries and tomatoes. But now there is a new focus on crops like cucumbers, eggplants, capsicums, and leafy vegetables. Even fruit trees, tropicals and temperates, and grapes are being trialled with protected cropping in new orchards, using hail netting combined with high density systems and dwarfing rootstocks. This is all about de-risking production and maintaining quality to market. When I use the term protected cropping in this presentation, I'm kind of talking about everything from hail netting to polytunnels to glasshouses. There are some real benefits to protected cropping. For example, more growers are using hail netting to stop things like sunburn caused by solar radiation, damage from hailstones, which can bruise and damage the outside of the fruit, even bird damage, which can cause $300 million of damage annually, but is really hard to control because all those birds are natives and can't be killed. So what's the issue with protected cropping? Well, by controlling the environment, we are severely altering that to the detriment of honeybees. We are increasing the temperature and humidity. We are limiting access to flora resources, and we are altering light and airflow. And anecdotally, growers and beekeepers have noticed a difference in the pollination ability and health of honeybees under netting. But we lack that hard data to really show there is a cause and effect, and that's where this project will really shine. Despite the benefits of protected cropping systems, causes of yield deficits have been attributed to lower plant and pollinator performance under enclosed conditions. This project targets methods to optimize honeybee and pollinator performance. At present, honeybees are introduced into many protected cropping systems for pollination, but their performance is often compromised by the conditions they experience, such as greater humidity and temperature, and the impact of low UV light. There is lack of specific knowledge on how to maintain hive health and maintain their performance in protected cropping environments. This project will focus on developing best practice resources that optimize the efficiency of the commercial hives and natural pollinators found in the system that are used in protected cropping environments. As you can see in the overview, we'll be looking at the effect of protected cropping on hive health and how we can improve pollination in those environments, and possibly even include mechanical means to supplement honeybee pollination. This will allow beekeepers to better prepare hives and the technology to improve, with growers able to innovate how they see pollination and use pollination in existing cropping systems. This will benefit cross horticulture, not only those industries currently under protected cropping, but those looking in the future of how they can implement protected cropping to benefit their industry. So now we're going to jump into some preliminary project findings and get an understanding of what is being done under this program. So one aspect we are looking at is trying to understand the effect of netting on numbers, abundance of insects visiting flowers, and that includes the time they actually spent on the flowers. We have some questions including, does the canopy height above the crop affect bee health and orientation? Do bees need access to outside floral resources? Are bees effectively moving pollen under nets? Does netting require perhaps different orchard design and different hive per hectare recommendations? How do nets affect natural biodiversity of pollinating insects, specifically native pollinators, which can contribute up to 30% of pollination in some systems? Nets may even alter the environment so much due to the physical barriers they actually present to wild pollinators that growers may need to consider more hives per hectare to make up for the numbers of lost wild pollinators. So far, results have shown difference in insect abundance and amount of time insects spend on flowers. And you can see that in the graph below, where there is vast difference in not only insect numbers, but the time they spend on flowers, comparing open field systems to closed netting systems. So why is it important that insects spend more time on flowers? Well, time is equated with likelihood of pollen sticking to the body of the insect, and therefore likelihood that the pollen is moved onto the stigma of the next flower, pollinating and creating fruit set. One way we have experimented in encouraging more insects and their activity under nets is to actually open some of the overhead rows in pitched netted blocks. Honeybees and other flower visiting insects have reacted positively to this change. Having a clear space above the trees planted under nets was associated with higher rates of flower visitation by insects, with some growers opening up the sides or above the canopies when able to. So it seems we have a clear solution. However, opening the nets costs growers a lot of money, and it also opens up to risk of environmental conditions that they're meant to be protected from. At the end of the project, we may be faced with no clear winners, i.e. a method that both benefits the beekeeper and the grower, but rather a better understanding of the effects of protected cropping on bee health and the need for more consideration on how they are placed in protected cropping environments. This will be important when planning for the future and understanding how to price hives per hectare and how many to request. This will build better relationships between the beekeeper and the grower for the future. This project not only looks at how bees move under protected cropping, but also the impact of the location of pollinizers. The location of pollinizers can really impact cross-pollination, but are often planted at the edge or in only one part of the orchard to ensure harvesting can be done effectively and efficiently. In open field conditions, we know bees are generally okay in moving pollen over large areas and accessing the right pollinators to ensure effective cross-pollination. However, the compounding effects of protected cropping environments may be impacting the appropriate movement of pollen. So this is something we have done, and as you can see below, we have seen a strong edge effect occurring in these environments. This could mean that growers have to plant more pollinizers, or something that we're experimenting in is creating mobile pollinizer units. So bringing the pollinizers to the bees in those areas. Aside from the work in netting, we've also found some results of the effect of polytunnels. Distance and length honeybees spend under tunnels seems to have an impact. Honeybees visited more flowers in shorter tunnels when compared to longer tunnels. Overall, honeybee flower visitation was found to be higher under netting than compared to polytunnels. The distance from the tops of the trees to the material in general has been found to be an important factor of honeybee visitation. The higher the netting and polytunnel above the crop, the better for honeybees and the more visits. This work is ongoing. So how do we measure and track bee movement? Fluorescent powder is used to mass mark bees as they leave the hives. By tracking the bees and knowing where they came from, we have found that bees from colonies located under the netting were more likely to be found foraging in the middle of the block. Bees located on the outside and edge of the block tend to stay in those locations, as you can see here. The top figure shows bees from the hives under the netting, the orange and pink hives, spread down and across the rows of apple trees, whereas yellow marked bees stayed close to the edge of the block, and no blue or green marked bees were detected in our survey. This pattern may reflect an unwillingness for bees to forage under netting when they are located outside the block. The bottom picture shows a second covered block where marked pink bees from hives in the middle of the block were present in much higher numbers in the block center, while the unmarked bees, which were wild bees, were present in high numbers on the outside. Again, this reflects a pattern that bees located in the middle of the block are happy to be there, while bees outside the block aren't really willing to come further into the middle. Overall, there are indicators that there is potential opposition between hive placement recommendations and those recommended for hive health, i.e. it's better for the hives in regards to their health to be located on the outside of the block, but as we can see in the below, it is better for pollination if we have more hives spread throughout the orchard block, especially in the middle. This is something we'll continue to explore further. I mentioned that hive health is influenced on where they are located in covered blocks, and this was measured by comparing hives located in various positions around a covered block orchard. So the way we measured this was by comparing hives in open controlled environments in open fields, by having hives on the edge of covered blocks, by having hives completely in the middle of covered blocks, and by also having hives in the middle of covered blocks but with a gap overhead. Colony strength was assessed in the morning after hives were deployed, and this is by counting numbers of bees on frames to the closest quarter of a frame. They were again assessed before they were taken out of the orchard. This was done in the morning prior to foraging so we could get a great estimation of numbers of bees and equate that to hive health and strength. Honeybee colonies under the netting lost significant numbers of their adult bees, while colonies in open blocks continued not only to perform better, but actually increase in strength and health. So in contrast, the colonies located under the netting declined in strength, losing an average of 1.4 frames, which amounts to around 11% of all bees. These results tend to show that to prevent bee losses, it may be best to place the bees on the edge of the covered blocks or at least under gaps in the middle. This is to maintain their health, but also maintain their performance. Another really interesting aspect of this work is looking at understanding floral biology to optimize productivity. For example, the attraction of honeybees to blueberry flowers is actually nectar. Unlike other flower species, the honeybee is less likely to be collecting pollen from blueberry flowers, but instead focusing on the nectar. This means that during blueberry flowering periods, we may need to provide other pollen resources to maintain bee health while they're working in blueberry systems. So far, this blueberry work has been produced into a fact sheet, which will go towards our larger best practice guides, which will be done at the end of the project. As I mentioned earlier in the presentation, this program also involves looking at alternative methods to boost pollination through mechanical mechanisms. Different crops require different pollen collection techniques due to their different issues. For example, cherry pollen is considered quite sticky, while seed crops are generally not very attractive to honeybees. Work is being done to review pollen viability and storage to enable mechanical pollination technologies to be used to supplement crop pollination, all in the name of boosting pollination in these protected cropping systems. The next steps for this work is to develop protocols to measure pollen quality and understand the pre and post collection factors that impact pollen viability. This can include things like the cultivars, the growing environment, and also storage conditions. Scalable pollen collection prototypes have been designed and evaluated for onion crops, but work is still ongoing for cherries. The aim is not to eradicate the need for honeybees, but instead supplement pollination for ultimate success. So thank you for coming on this deep dive with me into one of our many projects. I'm always happy to chat, and as you can see, my details are listed on the slide, and I wish you have a great day. Thank you for your time. Bye.
The New South Wales Department of Primary Industries Tocal College is proud to launch 2 new online courses: nationally accredited pest and disease training for honeybees and beginning in bees, both available now for enrolment on our Tocal College education website. Tocal College has published close to 100 books on all aspects of agriculture and land management. All of our publications are up-to-date, best practice, accurate and reliable references relevant to modern ag. They are easy to read with useful illustrations and photographs for practical understanding of the subject matter. Printed and electronic, Tocal's publications in beekeeping titles include Honey and Pollen Flora of South Eastern Australia, Bee Ag Skills, and our ag guidebooks, Healthy Bees, Queen Bee Breeding, Honey Harvesting and Extracting, Pollination using honeybees, and Australian Native Bees, available now from our online bookstore. Thanks for tuning in today. As a reward to all our loyal listeners, we would like to offer 10% off all publications on honeybees. Head over to the Tocal bookstore to make your purchases before the end of the weekend.